Welcome to everyone. Happy to see a crowd forming already to join the first of a two-day workshop. It's one of the STEG thematic workshops. This is the workshop for themes 3 and 4. Theme 3 being agriculture and sectoral gaps, and theme 4 being spatial frictions. I'm Doug Gollan, one of the STEG academic leads. And I really have a very simple job, which is just to welcome everyone and to introduce the chair for the first session today, who's Michael Peters at Yale. Just to say we're really excited to have, it looks like a great workshop set of papers. I'm excited to hear from the speakers. I think we've got, Michael, will you or Elise talk about what people do if they have questions? Do you have all right, I'll let you do that, Michael.
I can do that.
Welcome, everyone. We've got, I guess, a 4-hour program today, something like that. But please come back to join us again tomorrow at the same time. Michael, let me turn things over to you to kick things off.
Wonderful. Well, thanks, Doug. Thanks for the organizers to giving me the opportunity to moderate this session. This is going to be an exciting session with 2 great papers. It's entitled Spatial Equilibrium. And I think these papers are really great examples of what the recent literature on micro to macro development is like, in particular methodologically, as we're going to see kind of both of them are going to try to build that bridge between general equilibrium models to get the macro impact, but using sort of reduced form, either RCT style or natural experiment identification. And so I'm excited to learn more. A couple of minutes about the ground rules. So we're going to have a 25-minute discussion, presentation, sorry, and then a 15-minute Q&A afterwards. Those of you who have some pressing questions in between, you can put them in the chat, ideally. So for the first presentation, which is Dan, and I see that Dan has his twin brother, also Dan Ehrlich, who also functions as Rob Townsend in the audience. And so Rob, feel free to kind of answer questions directly in the chat. Otherwise, I will also keep an eye on the chat. And if something pressing arises, I'll let you know, Dan, and then we can answer them in between. Otherwise, I'll keep a tally of all the questions, and then we can catch up in the 15-minute afterwards. So yeah, I think let's get started. We're excited to have Dan kicking it off on spatial spillovers about financial interventions in Thailand.
Thanks so much for having me. I'm really excited to be here, and it's great to meet all of you. Thanks again for all the organizers and moderators for putting this together. So hopefully you can see my slides now. Let me know if you can't. Oh, great. Okay. So I'll be presenting joint work with Rob Townsend on spatial spillovers and labor market dynamics, studying village financial interventions in Thailand. So the overarching question that this paper kind of tries to answer is, what are the spatial and general equilibrium effects of scaled up village level financial intervention? And this is particularly important when thinking about scaling up, because partial equilibrium considerations may not be the same as general equilibrium considerations, and they'll become increasingly important as projects are scaled up and increased in size. So one way to approach the question is kind of use what we know from the partial equilibrium to write a model and then kind of simulate the general equilibrium. We're going to be taking a slightly different approach, where we don't need to kind of take an a priori stance on mechanisms. We're going to instead evaluate an already scaled up intervention, document general equilibrium effects and key mechanisms. And then we're going to write a model to kind of interpret the welfare effects and run counterfactuals. There we go. So our work kind of relates to broad literature, and this is not an exhaustive list, and I'm kind of going to be brief here. But broadly, we're kind of be thinking there is an already existing literature on the GE effects of microfinance, and we're kind of going to be expanding on that by thinking more about the spatial equilibrium and the intra-village effects rather than the inter-village effects. There's also large literature with some fantastic papers on scaling up interventions that we're also kind of be related to. On the modeling side, we're going to be kind of building a dynamic spatial model where, in contrast to much of the literature, we're going to be including firm frictions and also asset choice on the workers. So the program we're going to be thinking about specifically is Thailand's Million Baht Village Fund program. So back in 2002, the Thai national government created village banks in almost 80,000 villages in Thailand, which is pretty much every village in Thailand. So already you can kind of see this was a large program. In fact, the scale of the program is around 1.5% of Thailand's GDP. So we should kind of be expecting to see large, both general equilibrium effects and spatial equilibrium effects between villages. What makes this program kind of nice to study, at least for us, is that every bank is endowed with the same amount of money, regardless of the size of the, each bank and therefore each village was endowed with the same amount of money, kind of regardless of the size of the village. And then it's going to be 1 million baht, which is around $24,000 in 2002 US dollars. This is going to generate quasi-natural variation in credit per household at the village level. And this kind of assumes that village size is exogenous, and there are like several a priori reasons to believe that is the case. The key among them is that villages were at the time thought of more as geopolitical units rather than economic units. And so villages were often redistricted for like seemingly random reasons. There are often multiple government agencies kind of competing with each other over village sizes. And so there was a lot of redistribution, and village size was often exogenous or is exogenous to the variables that we care about. There are other kind of tests that we've run that kind of confirm that this is the case. And in previous work, Geographic and Townsend kind of also do various tests to kind of make sure that this is indeed the case. The other nice feature is that the program was unexpected. In 2001, there was a national election, and this was the campaign promise of the underdog, who was unexpectedly won and then very rapidly implemented and put this program into place. So he won at the end of 2001, and by the end of 2002, the program was already put in place, and many of the funds were like almost entirely lent out. So it was very rapidly implemented. The program kind of worked like as a microfinance loan almost. These banks loaned out money to villagers in their respective villages, and then these villagers were then expected to pay back the loan with interest. So as I kind of mentioned, this program was studied extensively in the past, but primarily at the village level. We're kind of going to be adding a new dimension to it, which is kind of these village linkages. The data we're going to primarily be relying on is Thailand's Community Development Department panel, which is this biannual survey of rural villages from 1986 to 2011. The full sample is going to have around 40,000 villages. Importantly for us, it's going to include information on village wages and village populations. We're going to be actually then merging in GIS data of Thailand's road network to kind of get at the spatial linkages involved. And we're going to also be merging in the Townsend Thai data, which is for a smaller sample of villages, but will have better data on the sorts of mechanisms that may be at play. And in particular, things like trade flows and capital flows. So the baseline specification that we're going to run is equation number 1 on the screen. On the left-hand side, we've got the wage in village I at time t. And on the right-hand side, we've got beta, which is going to be one of the key parameters of interest, times credit, which is equivalent to the inverse population size of a village, times post, which is just a dummy for post-intervention, plus some fixed effects. So this is kind of going to be the baseline intervention we're going to use. Baseline specification we're going to use, and we're going to kind of expand it to like study then, for example, spillovers or heterogeneity in spillovers and things like that. So in the interest of time, I'm kind of going to give you the highlights of the results. I'm happy to come back to them during the Q&A and kind of show you the actual tables. But since we only have 25 minutes, I'm going to kind of just give you the highlights. So we're going to document three general equilibrium effects, or 3 effects on wages. The first is what we think of as the direct effect, which is that increasing credit per capita by 10,000 baht increases villages' wages by around 1%. So if my village got more funding per capita, wages in my village are going to go up. The second effect that we're going to document is the spillover effect, which says that increasing credit per capita by 10,000 baht increases wages in neighboring villages by around 3%. So if village A gets more money and village A is located next to village B, wages in village B are also going to increase. What's interesting is that the coefficient of 3% is higher than the direct effect of 1%, and which we kind of attribute to the really close nature or the very tight spatial linkages in the geographic location of villages in Thailand. Often there may be up to 30 villages within 5 kilometers of another village. So they're very densely populated. And finally, the last effect on wages that we're going to kind of document is that there's heterogeneity in the direct effect, which is saying that increasing credit per capita by 10,000 baht increases wages in isolated villages by around 1% more than in centrally located villages. So these are kind of the three effects of wages that we're going to kind of document in the data. We then turn to kind of thinking about mechanisms and what mechanisms are at play in generating the spillovers that we observe in the data. We're going to start by thinking about migration. And so we don't have direct evidence of migration in the data. We don't observe migration flows, but we do observe aggregate populations in each village. And so we can essentially test whether or not populations increase as a test of whether or not there's increase in migration. And so we do find that populations do increase. And for every 10,000 baht credit per capita, we kind of see an increase of 3%. The next kind of linkage, and this kind of doesn't rule out necessarily commuting, but it does essentially include migration. It's one of the key mechanisms because commuting alone wouldn't generate population increases. The next we kind of turn to trade balance, thinking about trade, and we find that there's no effect on the trade balance or imports. And so kind of rule out trade as one of the mechanisms through which these spillovers operate. And then we're going to look at credit flows. In particular, for example, if village A gets more money in excess perhaps of what they could use, maybe they could loan out some of their funds to village B. We again look at credit flows of various kinds between households and between different villages. And again, we kind of find that there's no change in credit as well. And so we're going to attribute most of the spillover effects kind of migration. So now that we've kind of documented the general equilibrium effects and kind of the key and what we believe are to be the key mechanisms, we're going to turn to kind of building a model to help us kind of interpret what the welfare effects are, as well from the distributional impact, and then kind of think about counterfactuals in that. We'll be drawing on, like, again, several literatures. Rural villages in Thailand have been extensively studied, and there's lots of spatial modeling already available. And we're kind of going to be drawing from these two pieces to build a model that kind of fits our environment. We're going to obviously have to let a lot of ingredients go because otherwise the model becomes computationally intractable. But we're going to be choosing what we believe to be the key ingredients to kind of, and then thinking about the role they play in welfare analysis. So to start off, we're going to have N villages, and the model is going to be in discrete time. We're going to have two types of households. Households are either entrepreneurs, which are going to be labeled with an E, or workers W. Households' occupations are going to be fixed when they're born, essentially, so there's no occupation choice. And this may seem a bit counterintuitive because we know this margin does exist in rural economies. But in the case actually the village fund, we find, like previous research has found, that there's very little occupation choice switching in response to this program. And so we're going to kind of shut this margin down. And this actually helps solve tractability as kind of standard similar models. We're going to go with an open economy interest rate of 1 plus R. And we're going to allow for there to be an endogenous wage in every single village. Finally, we're going to have distributions of workers across villages and asset levels, which is going to be denoted with this LW. And this distribution can change over time and is unique in every village. And we're going to have similar distributions of entrepreneurs across asset levels and villages, which are going to denote with an LE. So to start off, we're going to start off with a worker problem. We're going to have a continuum of workers in the economy who maximize lifetime utility. They're going to discount time at rate beta. And they're born with different levels of assets, A0, that differ by both worker and village. So every village essentially has a unique distribution, has a unique population, as well as a unique distribution of worker assets. Workers are also going to provide 1 unit of inelastic labor. And we're going to go with the inelastic labor, particularly because it makes things easier, but also because previous research again found that in rural villages in Thailand, the wage elasticity is often low and insignificant. So essentially workers are going to provide the same amount of labor regardless of economic conditions and wages. And finally, we're going to assume that they can migrate from village I to J by paying a migration cost kappa ij. Kind of in contrast to previous work, we're going to assume that kappa ij is pecuniary, in part because we can actually simulate, so actually we're solving for the asset distribution. We're going to assume that this migration cost is going to come out of your asset. To kind of show you the recursive formulation of the worker problem, we're going to have their value function. We're going to write down their value function, and they're going to choose how much to consume and how much to save for next period, which is this A prime. And so they're essentially maximizing period utility from where they earn interest 1 plus R under assets A plus wage, and then they're going to save some amount A prime and consume the rest. They're then going to maximize the location, their utility, given the location choice of the problem. So they're going to choose location J from set M of possible locations they can move to. And M in this case can actually be constrained by, for example, having enough assets to pay out the pecuniary migration costs kappa ij out of the amount of assets that you've saved. And finally, there's going to be this idiosyncratic shock epsilon jt over location I and j. Kind of the key assumption that makes this value function work is the timing assumption about the timing of events. We're going to assume that workers choose assets A prime before choosing the migration before choosing a location to move to, and before observing the epsilons jt, which are the idiosyncratic shocks. So they're essentially choosing how much assets they without knowing first where they're going to move to. This timing assumption and an assumption about the distribution of epsilons allows us to kind of rewrite the value function in this more convenient form, which is going to be the equation at the bottom. And specifically, we're going to assume it's a type 1 extreme value distribution. And so again, this value function is going to be very similar to like previous spatial models that have that like dynamic spatial models, but now we're adding in this kind of asset choice into this mix as well. We can now derive migration shares as kind of standard in the literature. So we can let GW be the worker's asset policy function, and then we can kind of get a very familiar expression for migration shares. Again, the only key difference from like what you might be familiar with is this expression right here, which is the state variable in the value function, which is now going to depend on how much you've saved and also the pecuniary migration costs that you end up paying. But otherwise, hopefully, this should look kind of very familiar. And specifically, this value is the fraction of workers, or the probable. You could think of it as the probability that a worker who starts period T with assets A in village I ends up moving to village J at the end of the period. Once we've derived these migration shares, we can derive a law of motion for the distribution of workers, which is kind of going to be given by the next equation, which is just basically says that we're going to sum over all possible villages that you could move to, and all asset states, kind of derive the flow of workers from one village and asset state to another village and another asset state. And finally, we can get the labor supply in each village by just simply integrating over the asset states in that village. We can now think about the entrepreneur problem. And again, we're going to kind of start with this recursive formulation. It's going to be quite similar to the recursive formulation of the worker, except with two key differences. The first is that entrepreneurs can't migrate between villages. Whether or not this is not an assumption, I can't really tell you, but this is part of an ongoing work, kind of thinking about the importance of migration of entrepreneurs. We're kind of assume they're going to be fixed here and kind of produce only in the village in which they're born. The other big difference from workers is that instead of earning wage W, they're going to earn profits that depend on the amount of assets that they own, as well as their productivity. And then we're going to assume that the profit function is going to be the following. They're going to have a decreasing returns to scale production function. They're going to pay wages W for labor and pay interest R on rent and capital K. Finally, the kind of important part here is that there's a financial constraint or a leverage constraint on the amount of capital that they could rent. And this is going to depend on the amount of assets that they own. So they can only borrow less than phi times A, which is the amount of assets that they have. I'm going to get to kind of this in the future, but we're going to think of the village fund as a relaxation of this leverage constraint phi. Again, this kind of gives by solving the value functions, we can get a law of motion for entrepreneurs, where again, we get a policy function and we get a law of motion to kind of describe the evolution of the distribution. We can now define an equilibrium, which is just going to be a stationary equilibrium. It's going to be a set of wages for every village, policy functions for every village and asset state for both workers and entrepreneurs, and distributions of workers and entrepreneurs across villages and assets, such that given wages workers optimize, given wages entrepreneurs optimize, labor market clear in each village. So the amount of labor demanded by entrepreneurs has to be the amount of labor that's available by workers. And then the distribution of workers across villages and assets is stationary, and the distribution of entrepreneurs across assets is stationary. I'm not going to kind of talk about the computation of this, although I do want to briefly mention the computation because we're solving for value functions. And then for the wages, given those value functions, The computation is quite expensive, and so we can't simulate all 40,000 villages. So we're going to have to do some dimensionality reduction and reduce the number of villages that we're actually working with to kind of simulate something more reasonable than 40,000 villages. Our calibration approach is going to be to calibrate our model using pre-intervention cross-sectional data. So we're going to, for as many variables as we possibly can, we're going to kind of draw on previous research of rural economies in Thailand to get parameter values. So for example, for our production functions, our discount rate and things like that, we're going to be drawing from previous work of rural Thailand. The only real variable that we can't calibrate from previous research of Thailand is the migration cost matrix. So usually the way migration cost matrix are calibrated is, for example, by running a gravity regression. And so you either run a log-log regression or a semi-elastic gravity regression to kind of get at the relationship between migration and distance between villages. We can't do that because we don't actually observe migration directly, as I kind of mentioned earlier. We can only observe aggregate populations. So what we're going to do instead is we're going to calibrate the migration cost function internally using like a simulated method of moments. And again, we're going to calibrate this using pre-intervention cross-sectional data. Once we've done the calibration, we can then simulate the village fund in the model and run the same regressions as we did in the CDD data and kind of compare the regressions in the model to the regressions in the data. And this will be an external validity test of how well we've calibrated our model using cross-sectional data. So as I kind of mentioned, we're going to use a dimensionality reduction technique to reduce the number of villages in the model. We can reasonably work with anywhere between 25 and 100 villages. And after that, the kind of computation becomes too expensive. So what we're going to do is we're going to instead of working with all 40,000 villages, we're going to kind of assign villages on a line and kind of calculate the distance matrix using locations of villages on this line. We're also going to assume that the line is going to be a closed loop, so that villages on either end of the line can kind of have small migration costs essentially between them. So this is essentially a line, but that ends in a loop. And so you can kind of think of this as the circumference of a circle. So villages are along the circumference of a circle, and the distance between them is the arc length between these two villages. Then what we're going to do is we're going to calculate the distance to the nearest village for every village that we've simulated, and use simulated method of moments to kind of match to match the nearest distance distribution to the nearest distance distribution in the data to approximate what we think is an important feature of the geography. So I'm not going to show any of the results, and I'm happy kind of to talk about this in the Q&A, but kind of hopefully this gives you enough of like an idea of what exactly we're doing. Once we kind of simulate the location of the villages, we're going to then calibrate the value of, we're then going to kind of get the migration cost matrix. And the way we're going to do this is we're going to assume that like it takes the form of a semi-elastic gravity specification as a function of distance, which is right here. And so we're going to be essentially calibrating this psi parameter in the exponent. The way we're going to do this is again using cross-sectional data of using population data in 2001. So we're going to be calibrating psi to kind of match the variance of populations in the data in 2001. So when, for example, the reason we do that is when migration costs are very low, the variance of population should be very large because individuals can move very freely, and so they're going to move to the most productive places. In contrast, when migration costs are very small, we kind of get when kind of migration costs are larger, we kind of get different effects because the individual can't move, and so this affects the variance of population. Again, I'm going to kind of skip over the goodness of fit here. I'm going to come back to that later, but I think we do a pretty reasonable job of matching values and actually matching kind of this distribution of nearest distances in the data. I guess the one thing I'd like to mention though is that when we do kind of calibrate this psi parameter, we actually get very close to other values in the data or in other like estimated values in other papers using kind of this gravity elastic specification. So we get a kind of an estimate of 0.04, which is kind of similar to, for example, estimate of 0.07 in Alfred and all in their Berlin wall paper.
And just to give you a heads up, you got about 3 to 4 minutes.
Thanks. Sorry, I lost track of time. So back to the village fund, we're going to simulate the baseline economy, relax leverage constraints in a way that's kind of consistent with the model, and then simulate the new economy and compare steady states. So kind of as an external fitness, as an external validity test, we're going to kind of pair regressions of the same type in the model. We kind of do get somewhat consistent estimates of the same kind, that wages, although the parameters don't match perfectly, we don't expect them to, but we do kind of hit the ballpark between these two estimates, which we kind of are very excited about. So now kind of getting to interpreting welfare results, we can then kind of look at what is the effect on capital and entrepreneur profits. And the effect here is the direct effect is going to be positive, which is the first line in the table, and the spillover effect is going to be negative. And the reason for that is that if villages in village A go up more than entrepreneurs in village B want them to go up, people are going to migrate from village B to village A. And so as a result, entrepreneurs are going to lose workers. And so they have to raise wages as a result more than they would like to. So essentially we've got positive direct effects, but negative spillovers caused by migration. And it's kind of a unique feature of migration rather than, for example, trade flows or capital flows. There are also going to be distributional effects by worker welfare. So we're going to find that small villages benefit the workers in small villages benefit the most. Those are the villages that receive the most money, whereas larger villages receive less. We're also going to find non-linearities in some of the villages. So for example, as you can see in the largest village here in blue, there's going to be a non-linearity in welfare gains because there's essentially two costs here. The first is that workers have a lower bound where they can no longer save. And so at the lower bound, they're going to have a large increase in welfare. And then again, they're going to have a large increase in welfare because there's a pecuniary migration cost. And so once that they earn wages higher than the pecuniary migration cost, they can essentially, again, have greater welfare by accessing higher wages in other villages. So we're going to run a couple of counterfactuals. The village funds allocate credit inversely proportional to population. As an alternative, we're going to allocate credit proportional to population. We're going to find that aggregate welfare is going to actually increase in this scenario, particularly because welfare for entrepreneurs is going to go up. And the reason for this is because we know it's because of this trade-off between the direct effect and the spillover effect for entrepreneurs. When wages are essentially when credit is essentially allocated proportional to population, the direct effects begin to dominate the spillover effects because there's less migration and therefore less of a trade-off between entrepreneur and worker welfare. So kind of just to conclude, why do we need a model of multiple villages to think about scaling up? Well, for two reasons. The first is that macro aggregates differ from one village model. And spatial frictions are important here in kind of mediating the result and distributional impacts of the program. This kind of brings us to two, that this village heterogeneity and spatial linkages kind of result in distributional effect of the policy on firms and workers, and in particular, this sort of trade-off. This trade-off may not exist with other sorts of spatial linkages, such as trade flows or capital flows, but is present with migration flow. So thank you. I think I'm out of time. Happy to answer any questions.
Perfectly on time. Thanks so much, Dan, for a very clear and great presentation. So before opening up the floor, I'm going to just use my authority here of having an open mic to ask the first question. So one thing which I thought was really interesting and which I think is really a novelty of combining this sort of micro-founded, let's call it like Ayagari style, accumulation problem of assets at the individual level with the model of trade and migration and so on. And so one thing which I was wondering about, and I was wondering if you could maybe help me think this through. If I think about the equilibrium before you do the intervention, so do you have a sense on how do these asset distribution by village sort of look like? What I have in mind is your villages, if I understood this correctly in the paper, they kind of differ by 3 dimensions, right? They have a different productivity level, the Z, and they different size. And then obviously through the spatial topology, they differ kind of how close they are. Did you look at, who are kind of the, where does this income distribution, it's like the income distribution shifted to the rich in the high Z villages or in the villages which are very remote or which are very connected? And that would have kind of helped me to sort of think through what I would have expected to happen after this intervention.
Yeah, of course, that's a great question. So to answer your question, the so your question has several parts. And the first one was yes, that when workers earn more money and the richer villages or the higher TFP villages, they're also good. The asset distribution is kind of going to be shifted right. So there are going to be more people who are richer in those villages. Whether or not, to add kind of a caveat, we're not doing a great job, however, in kind of simulating this distribution of assets across villages, in particular because we don't have enough heterogeneity to kind of accurately simulate this distribution. And in part, this is because like you would expect there to be different wages within a village, whereas in our model, every worker in like village A is going to earn the same wage W. And so kind of this distribution is going to collapse to kind of several asset states rather than maybe the entire distribution. And so there's certainly a lot of progress to be made, for example, by introducing more heterogeneity along that front in terms of trying to simulate the entire asset distribution more like accurately.
I have some more questions, but let me first open the floor to the others. So Jonas, you asked like 2 questions. I realized that Rob already answered something in the chat, but you have another one, so feel free.
Okay, yeah, so then quickly on just the technical thing. So first, I didn't understand how the borrowing constraint you have, that so you showed this graph later and how this maps into the baht per village kind of variation. It wasn't exactly clear how you do this.
Yes, so sorry about that. I ended up going a little fast. The idea here is that the villages lent out, the village banks in each village lent out essentially the entirety of the amount of 1 million baht. So in actuality, like almost the entire 1 million baht was lent out pretty much instantaneously within a year and a half. So we're going to kind of model this as leverage constraints relaxing just enough such that all 1 million baht is lent out in each village. And so we're going to, because there's essentially variation per capita here, we're going to assume that the amount of baht is going to be scaled essentially by the amount of workers in each village, which is this LIW. You can kind of carry that over to the other side and divide it through. So that gives you the credit per capita. And then we're going to kind of assume that the amount of funding that like firms or entrepreneurs want to like borrow from this 1 million baht is going to kind of equal this equation here, which is going to be the change in the leverage constraints times their initial assets, which is kind of the maximum amount that they can borrow when they're constrained.
Okay, and just to understand this, so this means that for some villages already in the baseline economy, this is not binding, right?
Yes. So in practice,
and what is the fraction of them that's where it's binding?
It's 100%.
So in practice, so for everyone, it gets relaxed.
Yeah. So in practice, it's going to be 100%. Like we can obviously come up with values of TFP that are, or of the Z variable that are so high that it's not going to be binding in every village, but kind of we're going to, when we simulate the economy, we're going to kind of choose reasonable amounts of Z from the data, and we find that every village is going to be constrained.
Okay, thanks.
Julieta, do you want to go next?
Okay, yeah, so I think it's a somehow related question. So in the data, you find these gains in wages, which I think are very interesting. Here, most of that is driven, one by the kind of more capital accumulation, higher margin of labor, but the Z productivity term that you have in there is completely orthogonal to the amount of capital that is. And you could think that what is really happening, and I would be curious to know what is happening in the data, is whether these entrepreneurs are actually able to take newer opportunities that are perhaps more capital intensive and actually more productive. So the distribution of Z is not really orthogonal to whether you have capital or not. If you have, say, a simple technology where you have low, say, a primitive technology and a more capital intensive technology, part of that would be driven because of the Z, kind of the gains from the experiment are not so much, the fact that, yes, we're able to accumulate capital, but also that we're able to take newer technologies. So is there something in the data that you could use to discipline this or to look at this?
I think that's a great point. And we haven't really thought about that. The answer is that in the data we're currently using, the answer is no, we don't really have productivities. The way we're calibrating productivities is going back to previous work by Rob and his co-authors that kind of try to estimate productivities from production functions, and then we're using that distribution essentially that they've found to kind of draw on to calibrate our own productivities. I think it'd be interesting certainly to maybe go back and maybe see if that productivity distribution changes. I think most of the work kind of in this area thinks about occupation choice changes for a fixed Z or for Z varying for an individual, but being, again, as you pointed out, orthogonal or
And I
orthogonal
think it
to
would be
intervention.
nice, given the richness of this data, I think it would be really nice to explore whether that's, and perhaps, you know, it's a different paper, but I think as a channel for why capital deepening matters here might be interesting to look at.
I mean, just to
Go
repeat
ahead,
what
Rob.
Dan, right. The CDD data is the primary database with, you know, hundreds, tens of thousands of villages, and we have to rely there on what the headman is reporting on behalf of villagers, and they don't give us very much information about occupation. From my data, within far fewer villages, you can see more about what the households are doing, but we're still running this problem, you know, that small businesses, we don't have a large enough sample to say small businesses doing auto works or small businesses doing grain processing or something, which is ideally what you want to have. I mean, there are some hints of it in some of the papers that pure agricultural firms, rice growing households are somehow doing something a bit different. And in one of the 4 regions that experienced like a manufacturing boom, talent was less persistent, which is consistent with your question, that it may be that it's less persistent because they've shifted somehow. So thank you. It's a very helpful question.
Great. I think Bruno, you were next, I think.
Oh, yes. Thanks very much, Michael. I find this paper and methodologically and in terms of results also very fascinating. I was just wondering whether you can speak also to this literature on the gains from rural to urban migration. If I understand correctly, you're only modeling rural village economies, right? And some developing countries, there is a large inflows of migration from rural to urban context. So I wonder whether you can speak to this this literature as well, if you have any insights on that. Thanks.
Yeah, so you're absolutely correct. We're only modeling rural villages here. We're not modeling like big cities such as Bangkok. And you're also correct that like there is a lot of urban to rural migration. This really isn't the focus of this paper. We do like kind of study villages of different sizes, but they're all small enough that like you wouldn't consider it an urban area. I don't think we've really thought about its applications to kind of urban rural migration, although certainly there's some overlap in terms of in terms of modeling, like perhaps like if there are pecuniary migration costs, kind of as we've modeled them and as we suspect there are.
No, especially because there are like this literature that establish the credit constraints for migrating from rural to urban. It's a major barrier to development, right? And perhaps at least linking this policy with your model to these gains could be interesting, but I understand it's out of the focus to what you're doing here. But thanks, I understand that. That's great.
Yeah, but as you said, like you could certainly take this model and kind of think about slightly different questions and using these like pecuniary migration costs. Yeah.
Thanks a lot.
If this kind of matters, we kind of estimate that the pecuniary migration costs around 4 times the wage, which is quite large. It is kind of consistent with much of the other literature, which finds that migration costs are very large. And in part, this may be like a misspecification question and like that's broader to the entire literature, but we do find migration costs are quite large and it makes it difficult to move. So,
Great. Roman, do you want to go next?
Yes, thank you, Michael. Very nice paper done. So I have a question about the migration cost. So if I understood correctly, you are just calibrating the migration cost as a function of distance, but there can be like other bilateral measures between pairs of villages that can affect migration costs. I don't know, like in the context of Africa, like for example, ethnic groups, or like, I don't know, cross-state variation and things like that. So I was wondering if you think that it is important to include like other types of variables in that migration cost equation that you're estimating, and also related to that, if you can estimate like the migration, that elasticity that you're estimating, that psi parameter, if I remember correctly, is specific to each group, because I didn't know like if you are estimating that like for workers and entrepreneurs different, or if it is the same parameter. Thank you.
So to answer your first question, I don't think this is a big issue in our model or in our context. We're mostly looking at like small spillovers in scale. So we're not looking at spillovers across hundreds of kilometers, but spillovers, and I apologize for this, kind of when I briefly went over the empirical results, should have mentioned this. We're kind of looking at spatial spillovers in the context of like 5, 10 kilometers, and it's kind of robust to all of those, but like these are like relatively small distances, not massive in the sense that like we should be thinking about like different ethnic groups or things like that. So we do believe that like kind of the biggest barrier here isn't like, for example, different languages or different or ethnic barriers, but would be just migration, like just the cost of moving across distance. There are obviously also geographic costs, for example, like travel, like maybe there's a mountain in between. And so that's why you use the road network to calculate travel distance or travel time. That should kind of, in our mind, is like the biggest migrant cost to moving across villages in our context. For the second question, we're only doing this for the workers, and we're going to do this for we only really have one type of worker. We're going to do this in terms of skill level. We're just going to do this we're just going to have one Xi parameter. Entrepreneurs, as I kind of mentioned, don't move. So they're going to be kind of fixed in the location in which to live. And so the only people that like face this like pecuniary migration costs are going to be the workers who have to move across villages. So there's only one Xi in the model.
Great, thank you. And then, yeah, I guess we have time for one more. Ethan, go ahead.
Well, thanks very much. I have sort of a technical question, I guess. I was really interested in the way you're modeling space here by arranging villages along a curve. You said that you're using a circle as an example. I don't know if that's what you're actually using or not. Maybe it doesn't matter too much. It reminds me, one reason I like it, it reminds me of the monetary models that Rob was working on about 40 years ago, some of that spatial stuff. I'm curious though, really the question is how well that does. If you have villages on a circle, then you can describe the location of each of those guys just using a single angle. How much violence does that do to the distances between villages compared to what you get with a Euclidean distance matrix?
Okay, so a couple questions. They're all great questions. Start with the first one. Yes, we are actually using the circle and just using, as you said, the angle between villages as kind of a distance to have as like essentially the distance between the villages. We find that just like a very easy parameterization of this problem. It kind of helps us like keep things simple. And then in terms of fit, I guess it kind of depends on specifically what you're trying to fit to. So we're kind of, in this case, we're trying to fit to we're fitting the distribution of distances to the nearest village. I think we do a decent job of doing that, and we do that for different amounts of villages. And like the model and like the results I've kind of presented today, we've kind of showed you the results for 25 villages. And so we're not matching it perfectly because there's a lot, like it's a big distribution. We're only really matching one parameter, but we do a decent job in terms of matching the key. I think that some of the key moments, including like the skew, the kurtosis, and the variance, for example, and kind of deep in this table here. There's certainly work to be done here, and but that will require adding more parameters to kind of try to do a better job of matching them.
Thank you. I guess one quick follow-up. I mean, the rank of a Euclidean distance matrix would be pretty low. I mean, if you were choosing 2 parameters for location instead of 1, would that be feasible or not?
Yeah, so we could certainly, like, for example, simulate a square or like a rectangle or whatever, and put villages somewhere in this square and simulate that instead. And then we'd probably have more, we'd definitely be doing a better job fitting the data in that case. Yeah.
I'd just jump in and say we are avoiding the boundary problem this way, which is why these circles are always appealing.
Got you.
Well, wonderful. So we hit another boundary, the boundary of the time allocated to paper 1. Obviously, I encourage all of you, you can write emails to Dan and Rob afterwards, and you can connect. So yeah, let's just jump right into the second paper. This is a paper which might be close to Bruno's heart. It's going to tell us a lot about urban-rural migration. Allan, educational investments in spatial equilibrium. Are you still muted?
Okay, great. Thank you so much. I'm just arranging my window a little bit so that I can see the chat window. Okay. I'll
also keep an eye on the chat.
Perfect.
If you want, you don't have to worry about the chat. I'll remind you if something comes up.
That's perfect.
You can focus on your slides.
Wonderful. Okay, and you can see my slides. Perfect. So I'll go ahead and start. This is it's great to be right next to Dan and Rob's paper. To date myself and the paper a little bit, I remember at the end of one of Rob's lectures in the macro development field course at MIT, I went up to him and told him about some work I had done on kind of education and spatial equilibrium in Indonesia. So Rob, this is that paper. It's you know, it's written. Okay. So I'm interested here in how migration shapes educational investment. I think this is important because governments, of course, spend an incredible amount of money every single year on education, including in physical infrastructure, which is my interest in this paper. In particular, a large investment by the Indonesian government in the 70s, building 60,000+ new primary schools across the country. So the key kind of economic mechanism I'm interested in here is one related to space, of course. And the kind of observation here is that these schools serve students locally. They serve students within their region or their school district, what have you. But once students graduate, they can take that human capital that they've built and seek employment nationally. And I think this is important to realize for two reasons. One, because we can start to think about the non-local incentives for individuals to invest. That is to say, as a rural student, I'm thinking about wages within the national labor market that will encourage me to invest in education at home, where I live today. Okay. And two, we can think about the non-local effects of collective investment, in particular at scale. Once we build a lot of schools, people are going to get educated in their home districts and they're going to move around nationally. And so the effect of building a school over here is not only contained to this local labor market, but kind of impacts the entire national labor market via migration. So in this paper, those are the pieces that I'm after. I want to focus in on this Indonesian school construction program, this INPRES program, and use a model to quantify both its aggregate and distributional effects. From there, what I want to do is I want to lean into nice difference in difference variation that Esther Duflo pointed out in her job market paper. And I'm going to leverage that sort of old variation that Esther pointed out with new data, looking at long run outcomes 40 years past the point of school construction to think about long run effects. Now, that difference in difference variation, importantly, I'm going to marry with a spatial equilibrium model. And in particular, I'm going to be able to use that difference in difference variation to estimate the model in a credible way. Now, the point of having this model is that I'm then going to be able to decompose the net effects picked up by the difference in difference along various economic mechanisms, and also to redesign the program by simulating other school construction kind of configurations. So what I really want to get at here is this complementarity between education and migration. We want to think about these two phenomena jointly. One, as I said before, this rural schooling is going to depend on those wages in high-wage urban areas. These are those non-local incentives. And then two, when you build schools in rural areas, because rural students migrate to urban areas, you're also increasing urban output. Again, those non-local effects. The model is going to capture that. Lastly, just as a sort of preview results, what I'm going to find is I'm going to be able to quantify, kind of taking out all of the schools that were built and simulating the model. I'm going to be able to quantify the aggregate output gains from this school construction program to be on the order of 8%. And then I'm also going to be able to think about distributional effects and in particular inequality. And one nice thing here, I think, is that I can look at both person-based inequality, people from rural areas versus people from urban areas. But then we can also think about inequality across places, rural regions themselves versus urban regions themselves. The directions are going to be different. And what this is going to get at is this tension underlying, this sort of underlying tension for the social planner. If you really focus on rural areas with high returns to education, you're going to get bigger aggregate effects. That's going to be good for reducing gaps between people. But at the same time, those rural students are going to move to urban areas, and urban areas are going to develop faster than the rural ones. A bit of a distension between returns and convergence. So to kind of briefly hook into the literature, again, I'm thinking about education and migration at scale in general equilibrium. There are nice papers that think about sort of education at scale in general equilibrium without migration. There are nice papers that think about migration without education. There are a small handful of papers that think about both, But what I'm going to bring to the table is this nice quasi-experiment via the school construction at scale nationwide, and also be able to look at long-run outcomes. Okay, that is to say, I'm connecting directly to this rich literature kicked off by Esther on the in-pres school construction program. I'm adding here, thinking about aggregate effects, distributional effects, and running counterfactuals. And then lastly, I'm going to connect to this place-based policy literature. Where I'm going to differ a little bit is that normally in this literature, migration is going to water down the effects of investing in a given place. We also saw this in Dan and Rob's paper, where migration is giving rise to these negative spillovers via wages. Here, it's going to be exactly the opposite. Migration is precisely what is going to be generating the big gains from this targeted policy, because people are moving, and importantly, the benefits of that human capital are portable and they're taking it with them. So to give you a little bit of background, this is one example, one picture of one school built within this program. You can see it's very colorful and nice, a nice place to be a third grader. I have data on all of that, okay? I have treatment at the district level, these 62,000 schools. I know how many schools were in a given district before the schools were built, these in-pres schools were built. I know population rates, populations and enrollment rates, et cetera. This is data from Esther's paper, okay? I also am going to have individual outcomes in the long run. Again, this is sort of 35, 40 years past the point of school construction via Susana's household surveys. And importantly, these surveys are going to identify both the district of residence today and the district of birth. And that's what's going to tell me for this individual who happens to be living in this place in 2012, what was their treatment? Well, it's a function of where they were born. Okay, and then I know schooling and wages. And so what I can do is I can run Esther's diff and diff, and this is exactly what she's doing. Just to quickly recap, it's a difference in difference, two differences. The first difference is this comparison between the young and the old students. This is important because young students are treated. They're young enough to be treated by primary schools. Old students were already in middle school at the time the primary schools were built, so they're untreated. Okay, that's the first difference, young versus old. The second difference is districts with many schools, where the difference between young and old should be bigger relative to districts with very few schools. And so if no school was built, then young and old won't be that different. Okay, so the difference in difference, same as what Esther does, is what I'm doing. Okay, so I can show you those results. Education and wage effects, indeed what Esther finds hold up in the long run, 40 years down the line, positive effects on education as measured by years of schooling, and also wages as measured by wages. And then I have this nice placebo where instead of young and old, I can compare old and very old, and that goes through non-significant effects. Okay, and so here's where I start to diverge from what Esther did, at least in terms of the kind of causal inference part of the paper. I can also think about these non-local incentives. Okay, so what I'm plotting for you here is those treatment effects in different bins, and the bins are market access. And market access here is going to be a sort of inverse distant weighted population measure. You can just think of this as capturing being close to big urban centers. If you are in Jakarta, your market access measure will be high. And by market access here, I mean labor market access, by the way. Okay, so if you're in Jakarta, you have high labor market access because all of the high wage jobs are right there. If you live right outside of Jakarta, your market access is also high because you have those high wages from Jakarta, and it's not downweighted very much because the distance is close. If you live in a rural area with low wages and you're super far from Jakarta and any other city, then you have low market access. And what we find here, what we see here is that the effects are kind of not significant in those very isolated places. And the point here is just that if you're in a super isolated place, you can get educated, that's fine, but your returns to that education are low because you'll never become a programmer where you can really exercise that high human capital and get a big wage premium because there are no programming jobs either in your city or close to your city. Okay, and so those people are not responding to these schools that are being put in place. That was those non-local incentives. Now let's also think about non-local effects. Okay, and what I want to point out here is that base rates of migration are high in these places. Okay, something like 20 to 30%, especially for places with high labor market access. And then also, these are relatively far distances that people are traveling, 500–600 kilometers if they are a migrant. Okay, and so people are moving around, and therefore, given that people are moving around, building schools over here has an impact in other areas. So from there, we can go into the model. Okay, so this is the spatial equilibrium model. And what I have here is a model that kind of has three pieces, 3 steps. So in this first step, consider that the government builds schools, okay? And given these schools, students are going to go to those schools and build human capital that is portable and they take with them. Okay, again, this is portable, the portable benefits of this program. And the point of this is where the aggregate output increase is coming from. Okay, it's 1, people are getting educated, and 2, they're going to places that reward that education. Now, how are we getting to that point of being educated? Well, in the second step, conditional on the schools that were built, individuals are going to invest in education. And so I'm going to think about schools and education in a stylized way. I'm going to think about within a district, if there are more schools, then because access to these schools is better, there's going to be a lower cost of getting educated in those schools. The effective tuition is lower because you don't need to travel super far, okay? But all of the space here is going to be at the district level. I'm not going to have anything within the district. From here, then, individuals are going to migrate, and they're going to migrate for work. Okay, so they're not migrating for the schools. This is not going to be quite like moving to opportunity, where the migration is parents moving to districts, good school districts for their students. No, I don't have that. Students are born in a district, they get educated in that district. Conditional on that human capital, they're going to migrate for work. Okay, and so again, this gets at that tension between people and places. If you have a lot of mobility, you have a lot of roads, or you're in a really connected labor market, then as a rural student, mobility is great because it's going to allow you to pursue those high wage jobs in urban areas. And that's going to reduce person-based inequality because now the low end has bigger returns. On the other hand, those students, where are they getting the gains? It's because they leave after graduation. Okay, and so it's not going to help place-based inequality. So here are some of the equations. The key thing I want to get at here are the education and migration frictions. So there are migration frictions because this is a spatial model. There are education frictions because I want to capture the role of these schools that are being built. So let's think about an individual I from place J in a given age cohort K going to destination L. Okay, and so this is the utility of conditional on going to L. This is what you get. So you get amenities of L. Okay, if the place is good, more people want to go. You're going to get the base wage WL. Some places are highly productive and others not, and the highly productive ones have high wages. Your wages are going to be multiplied by how much human capital people from your given group have. Okay, some origins are going to have people with more human capital for whatever reason than others. I'm going to be able to estimate that profile of human capital over space. And then the human capital is going to be increasing in how much education E this individual I has. Okay, so a place can be really high wage, but if you have zero education, you're not going to achieve those wages. Okay, but bigger wages mean a higher return to education. Now, all of these, so all of these wages are going to be net of the migration friction. If you're going super far, it doesn't matter that wages are really, really high because you're not getting big gains from that because you have to travel back and forth to go visit your family, what have you. Okay, so migration is going to lower labor income. So all of that's the wage side. What's the education side? It's here. Okay, on average, tuition is C. Tuition C, the cost of education. And it's increasing, it's bigger in certain places, certain origins I, and for certain cohorts K because they have very few schools. If you have a lot of schools, then the education friction is going to be lower. All right. And so for every year of education, you pay that tuition. And why do you want to pay for that education? It's because it's raising your wages. So what's happening here then is that an individual is looking at all of the destinations. For every single destination, the individual thinks, how much should I get educated conditional on going to that place? Okay, and because you're going to have different freshet shocks, epsilon, in different locations. And so in some locations, you're going to have this high return to education and others lower ones. Okay, so you'll have a different level of education conditional on going to each place. That's going to give an indirect utility that's a function of that freshet shock as well as that education choice. And so then this is what we get, okay? This is a utility associated with any given destination, again, conditional on that destination-specific education choice. But anyway, it's a utility across destinations. Then what we can do now as the individual is compare the different destinations and pick the best one. And the Frechet distributional assumption here is going to give us a nice closed form for that choice probability that we see down here. Okay, so places that have high amenities have more migration. Places that are close have a lower migration friction, so you go there more. Okay, higher wages, etc. Now I can take that machinery and then I can get a closed form solution for migration probabilities of people from J going to L, of the average education of people from J going to L, and wages. And I see all of these in the data. And so these are going to give me moments. The other thing I can point out is that if I were to write these closed form kind of formulas for education and wages, you would see that each of them is increasing in this term here, which is the sum of the kind of adjusted wages across places. Okay, and this is going to be downweighted by distance. That's precisely the market access measure that I proxied for before. Education and wages are increasing in market access because it's increasing the returns to education. And then we can think about aggregate and distributional effects. I have a CES aggregate output, and then I can define inequality as follows. I can think about the difference in output or wages effectively for people from urban areas relative to rural areas. I can also think about the discrepancy between aggregate output in urban places themselves today, net of migration, versus rural places themselves. So people versus places. For estimation, given the time, I think I'm just going to go over the highlights and skip most of the details. The one key point here is that when I estimate the model, I'm going to be able to apply the in-pres variation directly. Okay, so for example, first I'm going to estimate this human capital function. I'm going to use the in-pres variation as an IV. I'm also going to think about education and migration costs. I'm going to apply the in-pres variation as a diff and diff. And then for these other parameters, which are not directly identified by the in-pres variation, I'm going to use indirect inference and use those in-pres estimates that we got from before as moments. Since this came up with the discussion between Raman and Dan, I'm just going to bring it up here. Like Dan and Rob, I'm kind of parameterizing these migration costs to be a function of distance, but I'm going to have physical distance as well as demographic distance. And I think this was what Raman's question was. In my case, because I'm thinking about longer distances, it's going to enter more. It could potentially be more important than it is in Dan and Rob's setting. Although I will say I find that really the demographic distance, and by demographic distance I mean distance in religion and language, doesn't really enter, and it's for me as well. Actually, it's really the physical distance that enters. Importantly, I also have these education costs, which are a function of the schools, and so I'm going to parameterize it in this both education and migration costs in this way. Plug that into the model. I'm going to get this equation here. So this on the left, the difference between education and wages I observe, it's going to be a function of these things that I can regress on and estimate parameters with. But what I want to point out here before I move on is that, for example, I'm regressing on SJ, which is the number of schools that were built. That's an endogenous object. Okay, that's going to be correlated with the error term. But I have the diff and diff variation from in-pres, right? And in fact, if you compare this to that sort of Esther's diff and diff specification from before, you're going to see that it lines up very, very much so. And so this is the sense in which that diff and diff variation from the in-pres program is what's going to allow me to overcome this endogeneity issue that absent the in-pres variation, I would need to assume away somehow. Okay, so that's estimation. From there, we can go to, with 5 minutes left, go to counterfactuals. So what's the goal here with these counterfactuals? So first, what I want to do is I want to evaluate outcomes relative to a counterfactual where I take out all of the schools. Okay, and so this is going to give me the effect of the schools. I can think both aggregate and distributional effects. Importantly, what the model is going to allow me to do is decompose these effects of mobility, for example, by mechanism. It's going to allow me also to separate these mechanisms from the general equilibrium effects that are going to be at play here that Michael at the very beginning pointed out are important and going from the micro to the macro. What I want to also point out here is that the diff and diff is, a statistical kind of object. The estimates from that are a statistical kind of finding that are true and valid. And those are going to avoid the model. But note, those are only going to capture the net effects. And it's going to be net also of the general equilibrium effects. I want to kind of separate these things out. the model is going to be useful for that. Lastly, once I have the model and I can kind of simulate alternative allocations of schools, I can also think about the design of the program. So this is really the main kind of result. Okay, the program increased aggregate output by 8%, but importantly, the main thing is how it gets decomposed. So first, let me think without any migration. If I shut down migration entirely, and I think only about the direct effect of building more schools, that's the difference between this top line, which is kind of been normalized to 1, and then building schools but not allowing anyone to migrate. Okay, that direct effect is only 2%. Now what I can also do is allow for migration, but without endogenous education responses. So this is just conditional on having education E, allowing people to sort into the place that is good for them by no longer shutting down migration. That sorting effect is also small. It's only 1%. The big kick in terms of where the real returns of this program are coming from, or once you endogenize education, and once individuals know that they can migrate, and once they see those high returns to their education, then they invest more in education. That endogenous response is what's driving 4% out of the 8 percentage points of this effect. And then I can also kind of allow wages to be set in equilibrium, and that's the general equilibrium effect. For me, that ends up being relatively small. So what this is really highlighting for us here is this complementarity between education and migration, and why it's important to think about the two of them together, at least in this context. And I also think this is important because other papers, for example, Mushfiq Mubarak and Garrett Bryan and co-author, have found that the gains just from that sorting, allowing people from rural villages in Bangladesh to go to urban areas by giving them bus tickets, those gains from pure sorting are already quantitatively large. Okay, and this is something that boosts all of that. Now, to talk quickly about distributional effects, they're going to be the biggest gains for rural students. That is to say that rural students have high marginal returns. When you build these schools, you're allowing them to benefit from those high marginal returns. And in effect, what that's going to do is going to raise up the bottom of the distribution. And so inequality between people is going to go down. And that's what I have here. Inequality between rural and urban students is going to go down by 5%. On the other hand, what's going to happen is that inequality across places is going to go up. Okay, and this is important because the program, regardless of what we think as economists, should we think about places or people, I'd argue that we do care about places for political reasons. And that's actually what you see kind of in practice. This program explicitly aimed to encourage regional convergence, but this mobility is going to place that convergence in tension with the output gains. What's happening here is those rural students are moving to urban areas. That's where their big gains are coming from. And so urban places are going to grow more than rural places, and that place-based inequality is going to go up. But I should note, and I'll tell you more on the next slide, note that these rural regions are still better off than zero school construction. It's just that the urban places benefiting more than they are. So inequality up, but the bottom of that distribution is still enjoying something from this program. And it's important as we really lean into this equity efficiency trade-off. And in particular, what I have in mind here is thinking about targeting both schools and roads. So suppose we target more rural regions, that's going to, based on what we've talked about so far, give us big returns. Okay, so I'm going to find that the returns in terms of aggregate output are going to go up by prioritizing rural regions with high marginal returns. But as I said before, inequality goes up. But now, importantly, it's sort of still a Pareto gain. And then I'll just wrap up in the next 30 seconds. It's still a Pareto gain because those rural regions are better off. But let's take seriously this complementarity between education and migration. If there is really strong complementarity, then maybe the policymaker should also think about schools in addition to building roads, lowering education and migration costs at once. That's going to generate massive aggregate output gains, but inequality is going to go up a lot. And once you build roads, people are going to leave truly rural regions. Outmigration is going to go up, and those rural regions are going to be meaningfully worse off. So this is no longer a Pareto gain. Okay, so just to summarize, what I've done here is presented a paper on evaluating large-scale educational investment in spatial equilibrium, thinking about both aggregate and distributional effects. And what I've really wanted to stress is this complementarity between education and migration. Thank you.
Wonderful. Well, thanks, Allan. Great paper, great discussion. Let me ask you one question which I had, and I think Jonas actually also put the same question in the chat. In terms of the modeling, I think you make this, or you made this modeling choice that people can choose their educational investment kind of catered to their particular destination, right? I was just wondering why you went down this road. Like, I would have thought, if I had thought about this model, I would probably had picked sort of a timing assumption, which was a little more what Dan and Rob were thinking about. You know, you make an educational choice, you anticipate the possibility that you might move to Jakarta. So there's still going to be this, you know, complementarity of the rural wage, but somehow you wouldn't pick, you know, education to be specific to the particular labor market which you know you're going to go to. I was just wondering if this is just a sort of innocuous modeling choice, or whether you had a particular reason to go down the route which you went down to.
Yes, absolutely. Thank you for the question. The short answer is I think this is relatively innocuous. What it buys is this sort of very clean closed form for how these migration probabilities end up, because that education thing is sort of folded into here. If I were instead to have a timing assumption where education is decided upon first, considering the future possibility of moving to Jakarta, I think the qualitative things would all go through, because it would, if I'm close to Jakarta, it's more likely that I'll end up in Jakarta. It's more likely that I'll have high urban wages to take advantage of, and therefore it's beneficial for me to invest more in education today. So I think qualitatively it still goes through. This kind of modeling trick just allows it to be a little bit cleaner in the math. The other thing I'll note here is at the end of the day as well, this is just a static model, right? And so these dynamics of kind of, I invest in education today, and then maybe some kind of, you know, anticipating future shocks that then get realized and I need to account for, and migrating back and forth. I don't have any of that. So conditional on it being a kind of one-shot thing, I thought it was fine to just leave it this way. Yeah.
Great. So we have a couple of questions in the chat. Let me start with Jonas, because he also asked a question in the chat already. So here you go.
Yeah, thanks. Okay, so actually two questions. So the first one was just a slight technical question of, I didn't fully understand why you took the Duflo 2001 kind of as the benchmark to match, because so at least this Martin fuzzy diff and diff paper, I felt like that they were kind of showing that actually what the Duflo paper is doing is not exactly estimating the right effects. But I mean, I guess it doesn't matter in your case because you have the structural model, and then you kind of do indirect inference. But that's just a small point. Maybe the bigger question is conceptually, so the 8% you find, the output gains. So I find it a bit hard to think about this because it doesn't seem very big if you look at kind of the 70s to, let's say, the mid 2010s. Indonesia grew by like a factor of 15, right? And so then 8% seems kind of small, right? So and I know it's just kind of a static setup, so it's always hard to think about these growth effects, but I'm wondering whether there's any way in your model to kind of think this with it, to kind of see how that would scale.
Yeah, absolutely. Thank you. Thank you for the question. So I'll start with the second one. Yes, it's right that Indonesia grew a lot between the 70s and the 2020s, or the 2010s, but my 8% is kind of, consider the 2015 kind of GDP or aggregate output with and without the schools. And so it's, you know, you take off, yes, there's growth of 15%, but 15x, but then I'm saying instead of growing 15x, the growth would only have been 13x or something like that. So it's all kind of denominated in 2015.
Right, but what I'm saying is, you're saying the growth would have been 50 instead of 15, 14.99, right? Something like this. Like it's a tiny effect, the 8% versus.
I don't think so. It's 92% of the 15x. So it wouldn't be 14.99.
Okay, I thought it was.
It's all denominated
8%. Okay, never mind.
Yeah.
Okay, thanks.
And then the Duflo 2001. I mean, you know, certainly point taken. I thought that a lot of the new diff and diff literature was about kind of phase in over time of a given program, and then with the state fixed effect and year fixed effect, things can be more complicated. But I need to think through more carefully, sort of for this application in particular. Yeah, I don't have a good answer for that now, to be honest with you. Yeah.
Thank you. So we got Farid.
Great paper, Allan. I enjoyed your presentation. You made this interesting observation about isolated areas. So in addition to what you said, could be the following, could it be also part of the story? Like, is it just about migration of graduates to urban centers? But like, in addition to buildings, these guys want to have high quality teachers, which are more abundant in urban centers. It's just hard for these isolated areas to attract these high quality teachers. So just wondering how much you think this matters. In addition, I wanted to ask about the cost of this schooling program. Do you have a sense of like how costly it was for the government to run it?
Absolutely. So I'll answer the second question first because it's easier. I do have cost data on the schools that is differential by sort of in this region it cost X, in that region it cost Y. I do have that. And in fact, when I run these counterfactuals of, for example, targeting rural places more, it's not just increasing the amount of schools in the rural regions. I guess I could do that too. There's not necessarily anything wrong with that, but sort of it's taking the budget and pushing more towards rural regions. And I can hold fixed the budget, the overall budget, because I know the costs. I mean, Esther, I get it from Esther, and she has a cost benefit analysis, and I could lean into that more if I wanted to. On the isolated areas, the short answer is that I don't have any data on teachers. And so it's always going to be a bit limited what I can say along that dimension. It is the case that in Indonesia, there are sort of formal programs. You see this with doctors, you see this with teachers. And I think to a certain extent, this happens in the US in some ways as well, sort of incentivizing recent graduates to go out to serve rural areas, or think even Teach for America, for example. But at the end of the day, I just don't have data on that. And I guess the broader comment here is that people in the education literature are often going to have super detailed data that allows them to get at schooling quality. For me, schools are all a homogeneous good. I don't have that data to write this paper in the way that they might write it. But the benefit here, what I do have, is the labor market outcomes 40 years after getting educated. That long run general equilibrium effect, I can get that, but that's the trade-off. I'm going to have less on the schooling quality side.
That's fair. Thanks.
Bruno, urban-rural migration.
No, not this case now, but I was wondering if I understand correctly, you use a lot of the variation you get from these different exercises. And I wonder if you also use like variation on wages. I was asking myself whether you can separate like the educational gains from the choices of individuals from perhaps the general equilibrium effects of this massive construction program itself, because I believe it could have generated some general equilibrium effects, especially in the developing context of Indonesia. Do you have any insights on that?
Yes, so I can get exactly that. What I have here is the wage that I observe in the data is this kind of the base wage times human capital, and that's going to be a function of education, but it's also a function of this base wage thing. So base wages here are directly reflective of underlying productivity in a given place. So I can estimate this object, but then this object gets to move around in general equilibrium, because in the kind of CES aggregator, there's this substitutability parameter. And so because goods made in different places aren't perfect substitutes, what's going to happen is if everyone moves to Jakarta and you have a ton of output out within Jakarta, not everyone wants Jakarta goods, because it's not perfectly substitutable. So the demand for Jakarta goods, holding that fixed supply is high. So the price, if you will, that is the marginal productivity of making stuff in Jakarta is going to go down. And so this base wage is going to go down. That's the general equilibrium effect. And so what I can do in this decomposition here is I can hold fixed the base wages, which again are not exactly what I see in the data. The data are base wages times human capital. I can hold those base wages fixed, and then I can allow them to adjust in equilibrium. And that's the sense in which I'm getting the general equilibrium effect. So it is a bit of a, yeah, that's where
that makes sense. Now I understand. Thanks. That's great.
Thank you, Bruno, for the question.
currently I don't see anyone raising their hand, so I'm going to ask another question. I think what I really liked about your paper is to implement this idea that the returns to my education depends on my distance from Jakarta. And so if I just think about sort of that mechanism, it seems if I were to give you, exogenous wage variation in Jakarta, which kind of moves around, I guess the type of regression which you would have run is to kind of say, do I see that people in like the rural area close to Jakarta, that they go to school more now than the people kind of far away? And so I was just wondering, I know this wage variation is kind of hard to come by, but if you kind of thought about whether your data would give you sort of any variation which doesn't come from the supply side of schools, but really from the demand side for education, and using that variation, how far are people from the like catchment area where the good jobs are?
Yeah, absolutely. Let's see. So
maybe the answer is no, but it just seemed that, when I looked at your equation, that would have been sort of another way to kind of estimate some of these parameters.
That's right. I mean, I think what you're saying is in part a more sophisticated version of this. So here, what I'm doing is I'm looking at whether people who are super isolated. So you're saying, if the wages of Jakarta go up and down, then that's going to change market access differentially. And what I'm doing here is less sophisticated. It's taking market access as exogenous. People are just born in a given place, and that's where they happen to be born. But if you believe that, then that's what this is getting at. People who, given that it's exogenous where you're born, that's the assumption. People who have better access to Jakarta have, for exogenous reasons, a kind of better access to the Jakarta wage, and therefore a better Jakarta wage. And they are responding more on the demand side by investing more in schooling, and as the direct result of that, getting higher wages. And you don't see that for people who are super isolated.
Right.
Yeah, but I don't. That's the underlying assumption, and I think you're pushing me to go beyond that.
I think I would rather not so much in kind of having the market access change. I think what I would be very interested in seeing, and maybe there is some existing work of what I'm not aware of, is to sort of think about the conceptual experiment. Take somebody in market access quintile 2 versus market access quintile 5 relative to Jakarta. And then if I had an instrument or some exogenous variation, the wage for Jakarta, I could kind of trace out whether the educational response is high in the quintile. Well, I guess 5 is close, right? Is higher in the people which are close to Jakarta relative to not close from Jakarta. And so I think your variation is like slightly different, right? It's basically to say, if I see one school popping up, if I'm close to Jakarta, I'm more likely to take advantage to it relative if I'm far away. But it seems for this kind of mechanism on this catchment area, it would also be nice to have some variation which doesn't come necessarily from the supply of schools, but just variation in the returns, and whether or not people who are close to Jakarta are more responsive to these Jakarta wages.
Thank you.
That's a variation which is hard to come by. I just,
exactly. And that's why I gravitated towards given that on the supply side, I have this quasi-experimental variation, I didn't need to cook up a crazy instrument. And so that's what led me towards kind of really leaning into that. But you're exactly right. That kind of begs the question of, on the demand side, is there something that can also kind of help?
Yeah, I think it would be very interesting if, as you go to the data, if you could sort of think about something where, we have all these episodes in the last 20 years of like urban biased growth and, sort of secular wage growth, which seems to be particularly high in cities. And I was just wondering if there would be some variation which you could use to sort of tease out these educational responses from these cohorts.
Absolutely. Thank you.
But anyway, I don't want to monopolize the discussion. So we have 45 seconds left before we get into the break. So this is your opportunity to ask another question to Allan. Well, so then maybe let me close it like here. Allan, Dan, Rob in the chat, thanks very much for a great session. I think also thanks for the organizers of combining these papers, which complement it kind of very well. And if I'm not mistaken, I think there is a couple of minutes break now, and then we're going to meet again for session 2.
Thanks a lot. Great papers.
Thank you.
Pleasure. Thanks, Allan, Dan.
All right.
Yeah, go
yes,
ahead,
we can
Andres.
start. Yes, very good. Thanks for inviting me to moderate this session on climate change. And the first paper is by Roman Zarate on the real effects of climate change in the poorest countries, evidence from the permanent shrinking of Lake Chad. Roman, you have 25 minutes.
Okay, thank you very much, Andres, and thank you very much to organizers for organizing this workshop. So I'm going to present this paper about the effects of climate change in the poorest countries from the permanent shrinking of Lake Chad, and this is going to work with Remy Getwap, Federico Haslop, and Carlos Rodriguez Castellan. So to start motivating the paper, let me start with the definition of climate change by the IPCC that defines climate change as a change in the state of the climate that can be identified by changes in the mean for an extended period of time, typically decades. And the economic literature has taken two different approaches to study climate change. The first approach, which is more related to development economics, have been to exploit a year-to-year variation in temperature and rainfall and study its effect on different outcomes such as migration flows, welfare, or productivity. But by construction, they are not studying permanent changes as defined by the IPCC. The second approach, which is more related to the economics geography literature, has been to build like very rich quantitative spatial models, dynamic models most of the time, to simulate the future effects of climate change. But however, they have not studied like a shock that is in the past. In this paper, we try to combine like the advantages of both approaches by analyzing the shrinkage of Lake Chad. So just to give you an idea of the lake, so the lake was a lake or is a lake that is between four of the poorest countries in the world, Niger, Chad, Nigeria, and Cameroon. And it was historically the 11th largest lake in the world, and it was similar in size of Israel plus West Bank Gaza or El Salvador or Massachusetts. However, since 1960, the lake started to shrink, and here are like some satellite images of the lake. So here is the lake in 1963, and as you can see, the lake reaches its highest level at the beginning of the decade of 1960. Now, starting in 1960, and because there was a shock in a fifth country that I'm going to talk about it later, the lake started to shrink, reaching its lowest level in 1987, and as you can observe from the map, like the northern pool of the lake disappeared. Now, since 1990, there has been a small recovery, but still, like compared to early 1960, the lake has lost more than 90% of its water. And this is like a major issue right now because there are like major examples of shrinking lakes in the world that include both the developed and developing countries. So in the US, you can find like several examples such as the Great Salt Lake, Lake Tahoe, Lake Mead in Nevada, and in the rest of the world as well. So, for example, there's Lake Pupu in Bolivia, Lake Chapala in Mexico, the Dead Sea, etc. Now, what this paper, the research question that this paper aims to answer is where the shrinkage of the lake affected economic development. We think that in principle, there can be an ambiguous effect. You are losing a very important asset, which is water, but at the same time, you are gaining another asset, which is land. So in principle, we don't know which effect is going to dominate. Now, in order to answer these questions, we are going to use like two different approaches. The first approach is a reduced form approach in which we are going to collect data for 4 of the poorest countries in the world, Cameroon, Chad, Niger, and Nigeria. And we're going to build a panel data set of population at the subdistrict level from 1940s to 2010. We're going to find much slower growth rate of this population measure closest to a lake relative to other areas in these countries. And then we're going to build a quantitative spatial model that is going to have multiple locations and 4 different sectors, fishing, farming, livestock, and an urban sector, to estimate the aggregate welfare losses because of the shrinkage of the lake, and at the same time to study the effect of different policy interventions and how much they can mitigate the negative effects of the lake. And these policies are related to migration, land use, trade, roads, and cities. And I probably will not have time to explore some of these results, but I will just describe some of the results that we find. So in terms of the background and data, so you have here like the total surface area of the lake and its evolution over time. And as you can observe, the lake reaches its highest level starting in the early 1960s. But since 1960, there has been a huge decrease in the water supply of the lake. There is a small recovery in 1990, but in the end, we have lost more than 95% of the water of this lake. Now, why do we think that the shock is exogenous? So this comes from the characteristics of the lake. So the Lake Chad is a sink that is going to be fed by the Chari-Logon River system, which is a system of river that crosses 3 different countries: Chad, Cameroon, and Central African Republic. But its major source of water is coming from the mountains in Central African Republic. Now, the lake is an endorheic lake, meaning that all of its water evaporates. So if the water stops flowing, the lake is basically going to disappear, and that's what happened because of a shock in Central African Republic. So what happened is that there was a large decrease in rainfall in the mountains of Central African Republic in 1963. Because of this decrease in rainfall in 1963, the water stopped flowing from the Chari-Logon River system from these mountains in Central African Republic to the lake, and all of the water of the lake evaporates. Now, we believe that the shock is going to be unrelated to local conditions because it is a shock that occurred like hundreds of kilometers away. But this is going to be particularly true for Niger and Nigeria because the Chari-Logon River system doesn't cross these countries. Now, in the case of Chad and Cameroon, we want to control for the Chari-Logon River system. So in our main specification, we're going to include dummies for the subdistricts that are crossed by this river. Okay, so this is just a picture of how does the lake look nowadays. And as you can observe, like these were like previous areas in which there was water before. And now there are some small settlements. And in some of our policy simulations, we want to relate what happens if we increase like the property rights in this location. Okay, so the data that we're going to collect. So first, of course, we want to run like a difference in difference specification. So we need localized data before, during, and after the shock. So we're going to construct a panel of data at the subdistrict level for the 4 countries: Chad, Niger, Nigeria, and Cameroon. And the main sources are going to be the population censuses and colonial and post-colonial administrative accounts. Now, we're also trying to collect other different data sets. First, we're going to construct like some measures of rural population versus urban population using this Afropolis data set, in which they track like the population of cities across time. And we want also, like in the paper, to include other outcomes as well. So for example, we're trying to collect information from the demographic health surveys or nightlife data to understand what is the effect of the shock on other outcomes. And we're particularly interested in the demographic health survey because that will give us some measures of mortality. However, some of these outcomes are not consistently reported across census, which makes like a little bit difficult to run like the standard difference in difference specification that we're going to run. Now, for the reduced form, we're going to run like a panel difference in difference specification in which we're going to relate our main outcome, which is the total populations in subdistrict S as period T, with a treatment exposure measure, which is going to be the proximity to a lake. We're going to use like 2 different specifications. In one specification, we're going to use the Euclidean distance, but we're also going to run a more flexible specification in which we're going to construct distance pins. And then we're going to interact this with these time dummy variables that is going to give us like the effect of the lake after the lake started to shrink. We're going to include like subdistrict fixed effect, time fixed effect, and we're going to include like an interaction of a subdistrict characteristic interacted with time fixed effect to control for different variables. So in particular, we're going to include like a dummy if it is crossed by the Chari-Logon River system. We're also going to include like distance to capital and to largest cities, latitude, because this is an important gradient in geography and economic activity. And for the case of Nigeria, we're going to include all production dummies. To estimate the standard errors, we are going to take into account the spatial correlation. So we're going to estimate them using only spatial errors. And then we're also going to allow in some of our specifications for district-specific linear trends, which is this term over here. Now, what we're going to find is that population grew at a lower rate in the locations that are closer to the lake. So here are like the difference in difference results for the 4 countries. So what we find is that the long-run elasticity, for example, for the case of Niger is minus 0.31, meaning that the population in these locations grew lower than 27% relative to other locations. We find similar effects for Nigeria. Actually, like the long-run elasticity in Nigeria is a bit larger, is minus 0.37. And for the case of Cameroon, we cannot test for parallel trends, but we also find similar effects of minus 0.36. Now, for the case of Chad, because most of the lake, especially like the southern pool of the lake was located in Chad, we expected larger effects. So we're actually going to find larger effects for Chad. The long-run elasticity is going to be around minus 0.62. Now, as I was telling before, like this is a very parametric specification. So we also allow for a more flexible specification, which is going to be a little bit more parametric, in which we are going to construct distance means and analyze what is going to be the effect of the lake. So we construct like dummy variables for bins between 0 and 150 kilometers, between 150 kilometers and 300 kilometers, and between 300 and 450 kilometers. And what we find is the expected result. We find stronger effects in which for the locations that are closer to a lake. So, for example, this is the case of Niger. For the dummy between 0 and 150 kilometers, we get a long-run elasticity of minus 0.49 in 2001, minus 0.63 in 2012. And as we start like moving outside of the lake, the effect is going to be larger. For instance, the 150 to 300 kilometers dummy, the elasticity is only minus 0.42. And for the 300, 450 kilometers, the elasticity is going to be lower. In this case of 2012, it's not significant. Okay, so based on this very simple reduced form facts, now we want to do a model, and we want to build this model for 2 purposes. One purpose is to try to understand what are the aggregate effects of the losses of the lake. The reason is that when you run difference in difference, you are estimating just a partial equilibrium regression. So you are just estimating the local effects of the lake, but we want to understand what happened at the aggregate level. And also we want to use the model to understand the role of policies to mitigate the negative effects of the lake. So the model is going to be very simple. It's going to be a static model in which there are going to be multiple locations, in particular the 453 subdistricts that we use in our reduced form. There are going to be 4 different sectors in the economy. One is going to be farming, livestock, fishing, and urban. And in terms of the preferences, consumers are going to have a nested CS preference. So in the upper nest, the preferences are going to be Cobb-Douglas for the sectors. And in the lower nest, we're going to use like a very simple CES aggregator in which the preferences are going to be just an Armington model within each sector. For the production side, we're going to assume that there is going to be a Cobb-Douglas production function. The firms are going to, there is going to be a representative firm in each location, and firms are going to use 3 different inputs: water, labor, and land. And agents are going to face the typical iceberg trade costs that you have in trade models that we're going to calibrate using travel times. The market structure, both in the input and the output market, is going to be perfectly competitive. So there is a representative firm that operates under perfect competition. And then because of this recent evidence that external economies of scale can differ across sectors, and Farid is going to talk about that, we're going to assume that there are going to be agglomeration forces, but these agglomeration forces are only going to materialize in the urban sector, not in the agricultural sector. Now, the important point here is the migration cost and how do people respond to a shock. So in particular, we're going to assume that the utility of workers is going to be there is going to be a random shock that is going to be drawn from a Fréchet distribution. This Fréchet distribution is going to have a dispersion parameter eta, which is going to capture the migration elasticity. And this migration elasticity is going to measure like how sensitive are workers to changes in real income across location. Now, in terms of amenities, there is going to be some congestion externalities, which basically says that as the size of a location increases, there can be some traffic congestion, there can be more crime, So the amenities are going to decrease as the population of a location increase. Now, agents are also going to face iceberg migration cost across location. And because we do not have migration flows, we cannot actually recover what is the actual migration cost. So we're going to play around with these variables. And in some cases, we're going to assume that it is equal to 1. In other cases, we're going to assume that it is equal to infinity. And the idea here is to play a little bit with migration policies and to understand the role of labor mobility policies on the negative effects of climate change. Now, the good thing about Frechet shocks is that you get like a very standard way of calculating the share of people that migrate from location I to location J, which is going to depend on the initial amenities, the real income measure, and this iceberg migration cost. Now, because by the properties of extreme value type shocks, we can get what is going to be the average expected utility in the economy, which is going to be given by this measure over here, which is just a weighted average of the real income measure in each particular location. And this measure is going to tell us like what are the aggregate effects of the lake. Now, in this kind of models, an equilibrium is going to exist, and it is going to be unique if congestion forces are larger than agglomeration forces. In this case, the parameter mu captures the agglomeration force in the urban sector, and all these three parameters, which correspond to the migration elasticity, the congestion externality, and the expenditure sharing in housing, capture the congestion forces. Now, the point is, how are we going to calibrate the shock in this model? So, or how are we going to take the data to the model? So we're going to use, because we do not have like very disaggregated data at the sector level, to calculate total factor productivity, we're going to use land suitability indices. And for the urban sector, we're going to use like the population size in each city. For the expenditure shares, we're going to use some tables that we found in the late 1950s and early 1960s that describe like how much were like consumers dividing expenditure in these countries. And for the input factor shares, we're going to use like different studies that have estimated production function for agriculture or for livestock. So these are just like the parameters that we're going to use. And for the different elasticities, we're going to use like previous studies. To calibrate the trade costs, we're going to use the Michelin maps. So these Michelin maps provide like the evolution of road networks across time, in particular across the 20th century. So we're going to use the road network in 1965, and we're going to calibrate travel times. And then we're going to estimate a parameter that can transform these travel times into iceberg trade cost. And for the amenity distribution, we just can invert the model and recover the entire amenity distribution. So this is like the way that we're going to model the shock. So the first one is going to be a water supply shock. So basically, like there is going to be a loss of water in some locations, in the locations that are closer to a lake, and we call this a fishing shock. So there is going to be a water loss in all these subdistricts, and most of these subdistricts are going to lose like 100% of the water. Now, there is going to be some other shocks that we call productivity shocks. Because of the sake of time, I'm just going to show you like the agricultural one. But basically, what we do is first, we're going to increase productivity in some of these locations because there is going to be more land. So we're going to assign for each one of the former cells of the lake, we're going to assign the land suitability indices of the land suitability index of the closest cell that was outside of the lake. And we're going to adjust this measure by the population increase within former lake area, which is lower than 15%. And then, like for the land policies, we're going to play around with this adjustment. So if there is 100% of property rights, we're going to increase the population in those areas by 100%. Now, there is going to be a loss of irrigation, so that is going to be captured in a productivity shock. And we also find that the lake is going to have a cooling effect in terms of temperature and rainfall, and there is like some evidence that temperature reduces productivity and then rainfall increases productivity. So we're going to take this into account by using the elasticities from previous study to calculate like a productivity shock in terms of rainfall and in terms of temperature using some of the effects that we estimate in our reduced form. So these are like the aggregate losses that we find for the lake for different migration scenarios. So we're going to consider like 4 different migration scenarios. The first one is a migration scenario in which there is no migration. So people have to stay in the location in which they live. The second one is a migration scenario in which people can move across location, but those locations need to be within each country. The third scenario is a scenario in which people can migrate between Chad, Cameroon, and Niger, because these are the poorest countries relative to Nigeria. And then there is a fourth scenario in which there is completely free migration and people can move freely across the 4 different countries. So what we find is that the aggregate effects are going to be much larger in the no-migration scenario. There are going to be economic losses of the lake of around 7.5% of real income. Now, in the case of within countries, some of the locations to which people start migrating are like very poor locations. So these locations in which people start migrating are going to have like a negative effect of all these congestion forces. So in the case of the within countries, we're actually going to get larger losses, and the losses are going to be around 8%. And in the case of Chad, Cameroon, and Niger, like the losses decrease a bit, but they are still 7%. Now, when there is complete free migration and people can actually move to Nigeria, and especially to the coast of Nigeria, the welfare losses of the lake are going to be much lower and are going to be approximately just half of the welfare losses in these 3 migration scenarios. So they are going to be just around like 4%. In terms of which country is going to be more affected, Chad is going to be the country that is going to be more affected in these different migration scenarios. But you can see that in the case in which there is free migration, the losses are going to be much lower. And then for Nigeria, the opposite is going to occur. Like in the case in which there is free migration, actually people are going to move to these locations, and because people move to the location and congestion forces dominate the agglomeration forces, the losses are going to be slightly larger relative to the within country migration and to the Chad and Cameroon Niger migration scenario. Okay, now how we do with the model. So of course we need to make sure that the model is doing a good job. We don't have too much data, but we have like the aggregate sectoral GDP shares. So we compare like the model to the data under different trade elasticities and urban shares, and we get that the model is doing a good job replicating the data. And in terms of the reduced form, we get that we are explaining like 2/3 of the effect that we get on the reduced form. So for example, in the long run elasticity, we were getting like minus 0.36. Here in our model, we're getting minus 0.25. We believe that we are missing like part of the shock. We're not including mortality, for example, here. So that's the reason of the discrepancy between like what we're getting in the model and what we're getting in the data. Okay, and this is just like how do people respond to a shock and how do people migrate across locations. So in the left panel, we only have the within country migration. And as you can see, most of the people move to Chad in these areas over here. Now, when there is completely free migration, people are not going to move to the east of Chad. They are going to move more to the coastal parts of Cameroon and Nigeria, because these locations are still going to produce fish and they are going to benefit in some way from the loss of the lake, because they are going to gain some comparative advantage, some absolute advantage actually, because of the loss of the lake. Now we simulate our policies. I'm just going to talk about the land policies here. So we adjust like the productivity shock by the population. So we say like what happens if 100% of the population moves. And it turns out that the quality of the land in this location is very poor. So you can see that there are a lot of zeros here, which means that the land is not like, even if we increase property rights, the quality of the land is so poor that even by increasing property rights, we cannot mitigate the negative effects of the lake. And just to conclude, so there is like a big, an ambitious project that is called the Transaqua project, in which the governments in Chad are trying to divert the water from the Congo River Basin to recover the lake. And this is a very expensive project. So the total cost of the project is around $50 billion. And we estimate, like in our case, what will be like the best scenario in which we can get the benefits for recovering the lake. We approximate that we are going to have like, this is going to generate benefits of around $38 billion, which is only 75% of the cost. So from an economic point of view, it is not going to cover the cost. So like, if you ask us our advice, we will tell that it is like this project may generate some losses. Okay, so just to conclude, we find large negative effects of lake Chad shrinkage. the aggregate loss is going to be between 4 to 8%, depending on the migration scenario. And the aggregate losses are overall reduced if we reduce migration frictions, reduce trade costs, or increase the absorption capacities of cities. But land development, it doesn't seem that it is a good policy in this context. Thank you.
Thanks, Roman. I've been looking at the chat and I haven't seen any questions yet. Okay, let me ask a couple of questions and then give Roman a chance to reply, and then we'll go around for more. These are mostly clarification questions and then a question about methodology. So clarification is, I'm just curious to know how you model the water market. You see it as a resource that has a price, and so there's a market, and I'm wondering who owns the water and how you think about that.
Mm-hmm.
And the second one is, when you talked about utility, can you go back to your utility? I was no, in the one that you're actually going to use, I think the aggregate utility number in equation 3. So I would have expected that since in this specification, people are kind of defined by the location that they start in. So that's the I, and then they move to J. And in that setting, I would have thought that you can easily specify the utility of people in I, which would be the sum of I, or would be kind of just removing the summation over I and bringing the 1 over eta 1 over to the first parenthesis.
Okay, I see what you're saying.
But you do the whole thing, and then I wasn't as clear. I guess you're saying the point where people are born, there's also some kind of share at that level. Anyway, so those two questions, and then we go around for other questions.
Okay, so for the water market, I mean, we are measuring it as an additional input. So the water is just, let's say that first the supply is going to be of water is going to be inelastic, perfectly inelastic. So it is just going to be like vertical line. For the price of water, what we say in the paper is that it is going to be a shadow price. It is not going to be an actual price. But the owners of that resource are going to be the people that live in that location. So like we are assuming the same for land. So the owners of the resource are just like the people that live in that location. And when we include in the income, like because we're interested in these real income measures and how do they vary across locations, we include both like the price of land and the price of water in the income of the workers that are living in a particular location. Now, for the aggregate effects, so this is like, let's say this is the average expected utility in the economy. So you can actually do something, and I think that this is related to what you are saying, like ex ante, what will be like so people are born in a particular location, there is a shock. What is the ex ante utility of those workers? You can actually do that just summing across I in the denominator. So without it will be like without this I over here, yes, you have like the Frechet shock that is particular to the location in which individuals are born. And in that case, you need to remove this I over here and just have the 1 over eta here. And that will be not the average expected utility in the economy, because that will just be like the average expected utility in location I, in the location in which the workers are born. But this is just from the properties of the Frechet, and because we're assuming the same migration elasticity across location, you just get this functional form at the aggregate layer. So those are my two answers. I don't know if that's
okay. Thanks, Roman. Farid?
Very interesting paper. I mean, you mentioned Lake Urumia in Iran, and so people are extremely unhappy about that. I think similar to Lake Chad. And my understanding of the debate about that particular case is that it is not necessarily a productivity shock. It is a productivity shock to agriculture and fishing, but it's also an amenity shock. So now, if I'm not mistaken, you were defining your climate shock as a productivity shock, either to land or water or fishing. Could it be also the case that, or could you also find a way to make it, in addition to a productivity shock, an amenity shock? Because people attach value to biodiversity, you know, if the temperature is a bit cooler, etc., etc.
Yes, that's a great point, Farid, and thank you very much for the question. So yeah, we're like, you know, like right now, like we're just modeling the shock as a productivity shock, but we think that in the same way that it affects productivity, it can affect amenities. Actually, like if you look at Klaus Desmet and Rossi-Hansberg papers and Bruno's paper, actually they include like some part of amenity shock because of climate change. So we are thinking on how can we model the amenity shock. One option, of course, is just to calibrate the amenity shock in order to match like perfectly the reduced form results with the results that we get from the model. So we can calibrate the amenity shock that way. The other way that I think that it is going to be cleaner, it's a way in which we basically have like temperature and we have like the initial distribution of amenities. So what we're going to do is that we're going to relate that initial distribution of amenities to initial temperature, because the lake has this cooling effect that increases temperature in some locations and also decrease rainfall in some locations. We can actually create an elasticity that relates the amenity to temperature, and then because of the cooling effect of the lake is going to have an effect on amenity. So we can also include it, and I think that this is going to help us to match like these elasticities better. So it's a great point, and it's a well taken point. Thank you very much, Farid.
Bruno?
Yes, I was, this is more just a clarification thing. I really buy the sort of experiment that the lake chat provides for you in terms of how it affected the water basin and affected the lake. But because of this really major like climate shock that must have happened in these mountains, right, very far away from the lake, I was wondering, do you have any also evidence that such a stark shock did not happen in other regions that you might be also studying? I don't know, as well as the shock, the climate change a lot in those mountains also changed the close to the lake, and therefore could be confounding some of these results that also relate to the shrinkage of the lake?
Okay, that's a great question. That's a great point, Bruno, and thank you very much for the question. I think that, I mean, this is more related to identification, and you know how does like this temperature shock like spread out across space that can in some way like mitigate like the negative effect. So what we do is actually like include like different controls. So for example, in some way like this latitude that we're including as a control is controlling a bit for that how does like these shocks spread out across like the different locations. And when we include this latitude interacted with the time dummies, we actually find similar effects if we include them or if we do not include them. So that's one thing. The second thing is that, of course, like we're like including like time fixed effect, and that is going to capture like what is happening like at the aggregate level in terms of temperature and rainfall. So that's going to alleviate some of these concerns. And the third thing is that the lake is per se is going to have this cooling effect on temperature and rainfall. And that is going to be in some way, that is going to be not endogenous, but that is going to come from the lake. But this is, let's say, that a long run shock. So these cooling effects are going to occur in the 80s, probably 90s, but they are not going to occur immediately. And we actually observe when we run our regression that the effects materialize very, very quickly. So starting already in almost in 1970, you get these negative effects of the lake in Niger, and you also get these negative effects in Cameroon. So we believe that because the effects materialize so quickly, that there are fewer concerns about this cooling effect of the lake, and that there is some correlation between the rainfall shock that occurs in Central African Republic and the cooling effect that the lake has. I don't know if that answers your question, but
it does. Thanks, Allan.
Okay. Thank you very much.
We have time for two last quick questions. Allan?
Thanks, Roman, for the paper. One, you can skip, but I just wanted to highlight that I think that the Michelin maps data is really cool, and the fact that you have quality on roads. And then I'll skip my question there for the sake of time. My kind of more substantive question is thinking about how to apply this framework to other places where lakes are drying up, including in a sort of projecting out to the future sense. My understanding is that, as you think about spatial equilibrium, you need to sort of estimate underlying productivity of the land that used to be a lake, but now it's not a lake and people live there. And so I wonder if, it's a nice thing that you have this situation where the lake has already dried up, so you're able to estimate those underlying productivities because people live there now. But if you're kind of projecting out for a future lake that hasn't dried up yet, I wonder how you think about underlying productivity and estimating those parameters. And I think it might be related to your discussion with Bruno.
Roman, before you answer, let me just collect also Paula's question, and then we'll just wrap up. Paula.
Thanks. So very super interesting paper. One thing I was kind of wondering about, both in the empirical identification strategy and the model, is how do you deal with the underlying structural transformation trends, in the sense that in the model, you are fixing the expenditure shares at the value of the 1950s. And those, are probably changing over time. So, whether it makes sense for you to incorporate, some preferences that have varying shares over time. That's the first question. Mm-hmm. And in the empirical part, similarly, I guess one, concern, I don't know, very well the setting, but probably the areas close to the lake are more agricultural, and then farther away you find cities. So how do you deal with these kind of underlying trends of migration from rural areas to cities that could be partly confounding your effects if you are not trying to differentiate them out in some way?
All right. Okay. So thank you very much, Paula and Allan, for the question. So I first will go over Allan's question about how can we extrapolate some of this framework to our context. So I will say that right now, in the way that we're modeling the productivity shock is a very simple way. It is going to be difficult to include to extrapolate this to our context, in the sense that every area is different in some way. What we think that we can do, and it's something that we are doing for the productivity shocks, is that we're assigning to a lake the closest cell, but the land is not very good. But in other areas of the world, it can be dependent on the salinity of the lake and all these measures. It can be the productivity in the former areas of the lake actually can increase more. So what we're doing is, let's say that because this can happen in our location as well, what we're doing is that what happens if we go over all the range of the productivity. So instead of just assigning the productivity that's closest to a lake, we're assigning the productivity that is the highest value that you can get from this land suitability index. So that will be a way in which you can actually extrapolate some of the framework that we're using here to our context. Now, of course, I think at the amenity part that Farid was talking about, it's also important. In our locations, I think that water is more an amenity thing than a productivity thing. So we are also working on the amenity effect of the lake. Now, going back to Paula's question, thank you very much, Paula, for this for the two questions. I think that they are very important questions. So for the first question, which is about the structural transformation and that the expenditure shares are fixed. I totally get the point that the expenditure shares are fixed and that this can be changing over time. I think that, the model will be very easy to extend. Instead of having a Cobb-Douglas utility function in the upper nest, we can include just a CS utility function in the upper nest. And with that, we will be taking into account this structural transformation thing. That's an extension of the model that we're working on. And also, in terms of this, because these are very poor communities, I think that preferences can also be non-homothetic here. So we're also trying to include Stonegiri preferences, in which there is going to be a minimum consumption level such that expenditure shares are going to differ between the agricultural sector, and as a location gets richer, it is going to spend less in agricultural goods and more in urban goods. So that's something that definitely we want to take into account, and it's also something that is important for the mortality thing. Now, for the rural areas to cities, that's something that we do. I mean, like we actually try to estimate what is the effect of the lake in, like, let's say, in rural population versus urban population, and we do not find that the lake have an effect in the urban population. Now, I don't think that this alleviates your concern, because your concern is more like about like what if we are estimating some of the effects because the rural people are moving from the rural areas to cities, and that's the reason because we're getting these effects and not of the lake. So we run like some placebo tests in which there is like another lake, which is called the Lake Fitri, which is also in the Chad region. And the communities around Lake Fitri are like also like rural communities. And we run like the same difference in difference specification, but instead of using like the distance to Lake Chad, we use like the distance to Lake Fitri. And in that case, we do not find like any effect. So we believe that because we do not find any effect in Lake Fitri, and these are like very similar communities around Lake Fitri and around Lake Chad, we are actually dealing with some of these concerns that you may have.
Very good. Thanks a lot.
All right.
Roman,
Thank you very much, Andres. Sorry if I took that. I
no,
took 1 minute
we're
longer.
right on time
Okay.
and for the questions. Great discussion. All right. So we're moving on to Bruno.
Andres, we will have,
Yeah.
so in the schedule, we have a 20-minute break, and then we'll do a long session with 2 papers back to back after that. So if people want to refresh their coffee or continue this very exciting conversation, just go ahead.
Okay.
We'll see you in 20 minutes at 11:45 Eastern, or whatever means whatever you are.
Okay, see you in a bit.
Godwin?
Yeah, thank you very much. I think my question was it was addressed with the subsequent submission that was given by Roman, so I'm okay.
Okay, good. Thanks.
Thank you, Godwin.
So I was going to ask you maybe to say a little bit more about the methodology for calibration. To some extent, as I was starting to read the paper, I thought you were going to do exact algebra, just calibrate everything at the beginning. And then I guess the problem there is you would have to come up with a hard change for the productivity of each of the activities in each of the jurisdictions.
No, we can do
instead of
that.
doing that, you're doing, so yeah, maybe you can just...
So I mean, like, it is like, so the issue here is that when you are doing exact algebra, you have like initial migration flows, you have initial trade flows. And in our case, we do not have like initial trade flows or initial migration flows. The only thing that we have is population at the subdistrict layer. So one of the things that you can do, so that's one thing. The other thing is that usually you have like population by sector, or like you have employment by sector. So you will need like employment by how much the employment is divided in agriculture, how much of the employment is going to livestock, how much of the employment is going to the urban sector. And we do not have that. And because we do not have that, what we are doing is basically calibrating the model in the initial equilibrium with this total factor productivity measure. Now, what we can do is that once you have like all the A's and you have everything, you can actually calculate the migration flows and the trade flows across locations. And then you can do the hat algebra, but it will be like the same thing that we're doing. So it's equivalent. So we're not doing exact hat algebra, but I mean, it's something that you can do it. You can solve the model in hat algebra for the shocks. Perfect. But you need to calibrate it like at the initial equilibrium with some of these total factor productivity measures.
The key elasticities, like the migrational, well, you don't do a migration elasticity. You consider these different scenarios, right? Of no migration or full migration.
No, we have a migration elasticity. What we're varying in the different migration scenarios is the migration cost.
Oh, the migration cost.
But the migration elasticity, let's say that is fixed, and we took it from Desmet and Rossi-Hansberg paper, so we're using a value of 2. One thing that we can do, and it's actually something that is interesting to do, is that we can do some inference matching procedure in which we can match like the reduced form estimates with the model estimates to estimate like a migration elasticity, similar to what Ben Faber and Cecile Gobert did in the paper of tourism in Mexico. So we can actually try to estimate some migration elasticity for this country. Now, the problem is that to estimate the migration elasticity in that way, we need to make sure that we're capturing like all the effects of the shock, you know, because otherwise we will have an identification problem in the sense that we are going to want to estimate the migration elasticity, but we also want to estimate like very well the productivity shock and the negative effects of the shock. And in that case, it becomes like harder. So yeah, that's the issue, to estimate the migration elasticity that way. So that's the reason because we're taking that as given. But let's say that if we calibrate the shock in a very comprehensive way, we can actually try to do some inference matching and estimate the migration elasticity. And related to that, Remy is working on trying to get migration flows. So if we get migration flows, we can actually estimate some migration costs with some, with some functional form assumption, but we will be able to estimate migration cost and actually, you know, see what is the real distribution of migration cost and not playing around with this one or infinity, which is the thing that we're doing now. Thank you for the questions, Andres.
I wasn't it wasn't very clear on your answer to the utility.
Yes, I know. I know.
So you can estimate like for the thing that is very clear is the utility I, right? So let's say you are I.
Mm-hmm.
That falls out directly from the Fréchet.
Mm-hmm.
The ex-ante utility, before you get the shocks that determine where you would want to go, right? That's U bar I. And then, it makes sense to come up with some aggregation of U bar I to U bar.
But it is
what you're doing is you're using the same eta, and maybe there's a way.
Yeah, you can have like if you have nested Fréchet, you can actually have different elasticities. But the way that I'm thinking is more like you have migration costs. This can be like similar to commuting costs, and like the approach that I'm using is similar to the Berlin Wall paper, in which there is some utility at the initial level, at the location level, but in the end, when you aggregate those and you have like the same migration elasticity and the same commuting elasticity, you are going to have the same aggregate utility, which is this welfare function, which is just this sum across I and across J, which is the thing that they did in that paper. So I think that in their case, if the commuting elasticity is similar to the migration elasticity, you get this functional form. In my case, I will say that if it's going to happen, if the migration elasticity is similar across location, it's the same across location, so that we're driven like the shock from the same nested distribution. Okay, you're not totally convinced.
If you told me that people choose where to live at the very beginning, they are like just
but people choose where to live at the very beginning. Like when we calibrate the thing, people are choosing where to live. Based on the amenities and everything.
No, but they are born in I. And then they're born in a place and then they choose where to go. That's why you have the DIJ.
Yeah, but the DIJ is a shock. So what I'm saying is,
the DIJ is the
the DIJ is a migration cost. What changes the initial equilibrium to the after the shock? Is the shock. But the way that we calibrate the model is that we take into account all migration costs, and that you start with some people are born in some location, but I think
if people are born in some location,
I see your point. Yeah, people need to be born in some location. Yeah.
And then you said, for example, there's a stage where people are not born. I mean, it's sort of very abstract, but people are not born yet, and they're deciding where to be born, and then they get a Fréchet shock, and that Fréchet shock has the same shape parameter. Then you get exactly what you had. So it's like a veil behind the veil of
it's something to what you have in the slicing the pie paper.
Yeah,
because you have some aggregation like that. I mean, these are technical details that are important. So thank you for. Thank you. But I have let's say that when we calibrate the shock, when we calibrate not the shock, but when we calibrate the baseline equilibrium, let's say that those migration costs are also going to affect the initial equilibrium because we're recording this amenity distribution. So people are born in some location, but for the calibration, I mean, I don't know. That when you are calibrating the baseline equilibrium, you're taking into account like these migration costs and how do people move from one location to another. But yeah, I think that I would think more about this and this veil of ignorance because I think that it's an important technical detail.
I think it's a minor thing. It's just, when I saw it, I wasn't clear. And last question. So as you bring in the model and now people are moving and you're computing this aggregate utility, migrate the kind of efficiency of the original spatial equilibrium is going to matter. And in particular, you have this congestion and migration externalities. And so you assume, or your calibration is consistent with that inequality that you have as a sufficient condition for uniqueness, which is that the agglomeration is weaker than congestion forces. And so that perhaps would say that if people move towards congested places, then that's going to make the aggregate efficiency fall because you're congesting the already congesting places.
That's an excellent point, Andres. And I mean, we haven't thought about, I mean, in some way this related like in the different migration scenarios when we have that, for example, in this within country migration is actually generating larger losses than the no migration scenario. It has to do something with congestion externalities. It's the only way in which you can get that result like in these models, because like if you don't have any externality, you will think that as you reduce migration frictions, you are going to mitigate more the losses. So the only way in which you can get that the within country scenario is going to give you like larger losses than the free migration scenario. Then the no migration scenario is one in which like these congestion externalities actually materialize more. And so, I mean, I think that explains the result, which is basically like we're moving away from the first base equilibrium because of this externality more because of the shock. And we haven't relayed this to efficiency, but I think that it is a nice way to do it. And I totally get that point.
Yeah, maybe an exercise just for understanding this is shut down the externalities, right?
We did that. We did that, and we get that, and then we get the standard thing that I mean, there is another congestion force, which is a market force, which is the expenditure in housing, but that's not an externality, so it shouldn't have like any problem. But when we turn off, like we shut off like this congestion externality, we actually get the standard result that the no migration is going to generate more losses than the within migration. So you get like the standard thing that as migration frictions are reduced, the welfare losses are going to be smaller.
Roman.
Yes, Bruno.
Yeah, we still have some minutes, right? So perhaps I can.
We have like 5 minutes.
You just mentioned this thing on the on the expenditure on housing, right? That also works as a sort of dispersion force. And related to what Farid asked you about this amenity side on the shrinkage of the lake and everything, I was wondering, beyond all of this amenity side of the water, water is also a sort of good that must be consumed, right? Everyone needs water. And I wonder whether you consider also thinking water to be consumed in the utility function, you know, and
it can, I mean, we can actually do it. I think that, I mean, in some way it is going to have like some isomorphism with the amenity thing. It is just going to be part of the utility. The point is that if it is going to be part of the utility and households are spending some fraction of their income on it, or they are not spending any of their income on it, I mean, I think that it is a way in which you can model the same thing in two different ways. I would say that way.
I see.
So,
I mean, one thing that I see that could be potentially different is that by doing so, access to water would have a direct effect on the real income, right? Because we'll enter the price index as well as housing, right? But I see that perhaps for this dispersion part of the thing, or the direct effect.
Yeah, you can also do that, like in the amenity. So in the same way that water is going to enter to a price index that is going to, for example, if you're losing water, that is going to increase the price index of water. You can also just do like something similar, just shutting down the amenities. So in the same way, I mean, they're going to have like the same effect on utilities. They are going to have like the same effect at the aggregate level. So I mean, you can, I think that it is just two ways on modeling the same thing. But
I mean, it's a bit related to Andres's question at the beginning of like, if you had a water market, suppose you had property prices and this stuff got capitalized into property prices, and then that can help you to, that's one way of getting at utility. And then like, you know, to the extent that it comes in consumption or amenities or whatever, it's all going to get folded in there. And then that's where you can kind of, I wonder if it helps you distinguish between the two. I'm not sure. Like if it's an amenity, it'll get capitalized into property values. I mean, I guess you don't have property values anyway, but
I mean, there is a price of land, so I imagine that.
So then, but then I guess like if it's consumption value, it'll get capitalized into the price of land. If it's an amenity, it'll also get capitalized into the price of land. But maybe that's the point. Like these two things, as you just said, maybe they get at the same thing at the end. It's to get
this isomorphism, right? That you refer to.
Yeah.
And the fact that they both capitalize into the land price in the same ways.
Yeah. Let me say that. Okay, I haven't thought about the capitalized thing, and I think that is a good point, Allan. So let me think more about this. Like my initial thought is that it is just going to be something very similar, and it is just of modeling like the same thing in two different ways. But maybe I'm wrong. So I will need to think more about this. But I think that there should be some isomorphism between like price index or amenity thing. But I will think more about it. It's a point well taken. So thank you, Allan and Bruno.
And maybe you don't want to lean into the land price data that much. Like maybe you don't want to lean into it super hard if you have kind of data concerns. But that's a way of getting at. That's an equivalent of a water market at Andres.
Yeah, I think that, to be honest, I think that, for example, the comment from Paula, like talking about like CS preferences and that the expenditure share vary like over time and after and before and after the shock. I think that probably it is going to be more critical for us than this decision between how to model like the water market. That's my sense.
Yeah, I agree.
And maybe I'm wrong. All right. So thank you very much for all the comments and the discussion.
Thanks to you, Roman.
Okay, looking forward to your paper, Bruno.
Bruno, do you want to share your screen?
Absolutely. So let me go there. Okay, I suppose it's working, right?
Yes. Just wait 1 minute to start right on time. The good thing about this Zoom meetings is you don't have to go out and call people to come back in after their coffee, and
it's very efficient, at least with the
conversations.
Everyone is more punctual, I believe, and yes.
All right, we can start now. Thanks, Bruno. You're presenting on the geographic implications of our carbon taxes, and you have 25 minutes. So we'll go to whatever hour it is there, plus 10.
Okay, great. So thanks a lot, Andres, and thanks everyone for having me here. I'm very excited to present this new paper that advances research agenda that my co-authors, Klaus, which is present here, and will be happy to address chat questions, as well as Esteban. We are working very hard, which is a research agenda that we are trying to push on spatial aspects of climate change and climate change related policies. And the paper of today, specifically, we investigate the geographical implication of one of such a policies, which are carbon taxes. Taxing carbon is seen as a first best type of policy to mitigate global warming, following this very Pigouvian logic that by forcing the economy to internalize environmental externalities related to economic activity, it brings closer, narrows the gap between the private and the social cost of carbon. And therefore market mechanisms by themselves reduce the environmental burden of the economic activity in terms of carbon emissions and global warming, for instance. There are other policies that have been also designed to achieve this goal, such as trading schemes, for instance, but carbon taxes are becoming increasingly common, especially in developed economies or countries in the world of nowadays. But the issue of countries individually or unilaterally taxing emissions in their own economies is that it gives room to what is called economic or environmental leakage. Namely, the economic activity in the countries that are taxing emission moving away or leaking away towards other regions that are more permissive in that regard. That does not address the environmental issue related to the economic activity, because emissions are going to be taking place anyways, but just coming from somewhere else. And on the other hand, it induces a cost to this country that is trying to reduce emissions by taxing carbon in their economies. There is a consensus around this underlying cost of unilateral carbon taxes following this logic. But what we convey in this paper, the main message is that this argument is not fully complete and ignores one important aspect, which are the potential spatial effects of carbon taxes. I provide some intuition here in the context of the current globalized economy, in which the economic activity is distributed across the world's geography, and in which agglomeration and congestion economies are important forces shaping the distribution of economic activity across the space. There is room for at least a hypothetical situation in which the pre-existing spatial distribution of economic activity not being efficient with respect to this agglomeration and congestion forces. Now, how that relates to carbon tax, as I'm going to explain in the next slide, because carbon tax reshapes the spatial distribution of economic activity, it could also be hypothetically that it corrects some of these inefficiencies related to this congestion and agglomeration externalities. And therefore, by hypothetically at least inducing these efficiency gains from this side, this could offset or even overcompensate the direct cost related to taxing carbon from this distortive leakage effect that I explained previously. This is what we investigate in this paper, and this hypothesis at least holds for the case of taxing carbon because of two reasons. First, it is a tax that I explained that generates these distortive effects, shaping the geography in the spatial economy, the geography of comparative and absolute advantages. But because it is a tax and unilaterally set by a region, what would happen is that it will generate tax revenues for these regions that are taxing emissions. And if these revenues are then retransferred back to the economy, like rebated back, it would also reshape the spatial distribution of income in this taxing region, and therefore where people will decide to live and perhaps agglomerate around. And this agglomeration or these changes in the migration choices of individuals following this rebating or retransferring of the tax revenue could generate positive effects that could compensate this direct distortive effect of the tax. We verified that this could hold in a realistic setup in which we model the global economy, and we then simulate the effects of the European Union taxing carbon within its own jurisdiction and retransferring locally the tax revenues from this policy. And we will see that the effects of this policy will then favor the Europeans' non-agricultural high productivity core in relative terms, always compared to a benchmark case in which European Union does not tax carbon, by agglomerating or attracting more population to the European Union, especially on those regions, and making the European Union economy grow in size. So compensating this direct distortive effect of the tax. But because also that reshuffling in the spatial distribution of the economic activity takes place both within this taxing region, European Union, but also between taxing and non-taxing regions, this makes the overall distribution of factors across the economy more efficient. And therefore, in global terms, we also have some welfare gains in terms of efficiencies. So with this result, like the main message we convey with the paper, that it's more general than the European Union, but what we show is that with this European Union example or exercise, that a unilateral carbon taxes whose revenues are retransferred locally acts as a sort of place-based policy that redistributes income towards the high productivity regions that work on, say, industrial or non-agricultural sector within the jurisdictions that are taxing emissions, in this case, European Union. And then by playing with this retransferring rebating schemes, we see that these effects change qualitatively in the direction that we expect. This is, say, like the main things we do in the paper. That's what we do. But how we do that, we're going to develop a two-sector dynamic spatial integrated assessment model to then perform these two simulations and then perform this exercise with the European Union. So how this framework that we develop works, here for the interest of time, I'm going to be brief. I'm not going over the formal or the mathematical parts of the model, but I'm going just to explain all of the pieces of this perhaps ugly long name of description of the model, like dynamic two-sector spatial and integrated assessment model. The framework, the model we built has first this dynamic spatial component that is similar to what Klaus together with Esteban and David Nagy developed, that it is a spatial economic geography model in which we have an arbitrary number of locations in the economy that are going to be in our empirical setup, high resolution grid cells covering the entire globe. And in each of those, there are going to be producers that are going to be producing goods and possibly trading with other locations subject to trade frictions, and using labor and land as factors of productions, and how much they're going to produce and trade, how high are going to be the wages they pay or not, are going to depend on the fundamental productivities. All of this is super standard from the economic geography. And the dynamic side of the model, they are highlighted in the green color, is that agents are going to decide where to live dynamically based on the real income per capita in each location, but also firms take dynamic decisions in the sense that they invest in innovation, which increase the productivity in that location and generate spatially spillovers, which then generate dynamics and what they call the dynamics of the geography of development. That's the name of the paper. We add to this our framework uses this, but adds another piece, which is the multi-sector and the integrated assessment part, which is that first of all, we allow the economy to be composed by two sectors, an agricultural and a non-agricultural sector, like the rest of the economy beyond agriculture. And we allow the productivities in each of these sectors to be differently affected in terms of productivity, either positively or negatively, by climate change, which here is going to be global warming. And the part that makes the model an integrated assessment model is that we model also this feedback, this loop between economic activity and the economy as follows. The firms here in this model are also going to be using energy as a factor of production, which is going to generate carbon emissions, increase global temperatures, and as a consequence affect local temperatures across the globe heterogeneously. That will then affect the local productivities heterogeneously for each of those sectors differently, and therefore affect these dynamics to what we call the local sector specialization, in the presence of climate change, where the production of each sector is going to evolve over time and space. The final piece we add in the framework we're working with here is the taxing of the emissions of carbon, which in our framework is going to be a wedge in the prices that producers pay for the factor of production energy. By paying a higher price, the producers in the locations that are unilaterally taxing carbon, we generate a direct distortive effect in the economy, because then production is going to be more expensive. This location is going to be less competitive to produce goods, and therefore pay lower wages, and these locations are going to have lower income per capita. At the same time, however, as I explained before, these taxes generate tax revenues that can be rebated back to the economy, and therefore compensate this loss in the real income per capita from the distortive effect. And whether this trade-off is going to be either positive or negative, net of these two effects will depend on the mechanisms that I explained. Just 1 second to get some water. A carbon tax is obviously an increase, a local carbon tax is an increase in the marginal cost of producing for the local firms in this location that is unilaterally taxing carbon. And therefore that creates this direct distortive effect through the reduction in the revenue that the producers in these locations are going to have, as they're going to become less competitive to produce and export. But once these transfers are accounted for, once the carbon tax is rebated, the income per capita may increase if two conditions hold. The first one is that if the carbon tax is not large enough, so then the distortive effects are not immense in the economy. But on top of that, it would hold if the demand elasticity to changes in the shipping prices are not too sensitive, which is in our Ricardian trade model, disciplined by the trade elasticity parameter here, theta. If this value is low enough, the changes or the impact on the marginal cost of producing does not map one-to-one into the change in the demand, and therefore into the impacts on the real income per capita in the locations that are taxing emission. And therefore that could lead that at the end, the income per capita in these taxing locations could be even higher in the presence of taxing carbon. On top of that, then we have that this will generate more or less agglomeration in these locations if the parameters discipline the migration elasticity, which here is disciplined by this omega parameter. The migration elasticity is going to be the opposite, the inverse of this. This parameter is going to link this increase in income to the expansion of the local economy. And if agents in the economy are too responsive to changes in real income, there are going to be more agglomeration into these locations, which then by agglomeration economies and gains in comparative advantage, that will make then the economy that is taxing carbon even better off in terms of efficiency. So that kind of echoes some results from the trade theory on the optimal tariff argument, that because the demand elasticity is not the demand is not super steep with respect to changes in prices, and so the entire economy of everyone that is importing goods from this location that is taxing carbon, they are also paying for this tax, but the tax revenues benefit only the locals in the regions that are taxing carbon. It gives room for this increase in real income per capita, and therefore this agglomeration effects into those regions.
Bruno, sorry, just to ask you about that. In the optimal tariff argument, in this case would be, for example, if you had an export tax, right? So the tax is only paid if you are exporting, not if you're selling domestically. But here it's more like a production tax.
Exactly.
So,
when I refer to it's more about this sort of result on the optimal tariff argument that shows that when in the presence of market power, there is always some unilateral tariff that will make the exporting location better off. And here is kind of is in the opposite, because then it's something that is set at the supply side, but generates qualitatively similar results in the sense that the location that is taxing carbon becomes, and perhaps counterintuitively at the first glance, that location becomes better off if not taxing carbon. That's kind of the relation. Is that clear?
Bruno, this is Paula. One further,
Paula.
I mean, this requires an improvement in the terms of trade, right? That's the mechanism in the optimal tariffs argument. Is that, no? I mean,
yes.
The reason why
absolutely.
income increases is that you generate an improvement in your terms of trade because you are restricting your supply, right?
It's because it doesn't map one-to-one in the sense that the increase in the marginal price doesn't map into one-to-one into the decrease in the demand. But at the same time, because the tax is transferred, it increased one-to-one, at least in terms of tax revenue, in the real income that is going to be enjoyed in the location that is taxing carbon. Does that make sense to you, Paulo?
Yeah, but this is yeah, it's I guess, okay, it's like a monopolist argument, no? That the optimal price might be higher than what you're charging. No, that's another way to see it. No, and
the
then,
reason I was sorry, Paula, I didn't mean to.
No, but go ahead.
No, it's just this, just the idea that you were in perfect competition. Now you are, increasing the price, and that
Yeah, but the
gonna
problem there is that the way in which this normally works is you restrict, as you were saying, you restrict your supply. And the reason you do that is you're taxing exports, and then you don't export as much, you sell domestically. But if it's a production tax, as the one that they're considering, then there is no favoring domestic sales. So then you don't necessarily lower the supply to foreigners. And
what we favor here, it's in terms of favoring local real income. That's the main difference. It echoes this idea that there is a sort of distortion in which the economy that generates the distortion ends up being better off. But it's not that the two policies are equivalent or qualitatively the same. That's the thing. And especially the effects of this, and especially the multi-sectoral setup, two-sector setup that we are working with, are stronger in the locations that are more specialized in the high productivity, energy-intense industries, because also these are the industries that generate more tax revenues because those industries are more energy intense. Also, these are those that benefit more from agglomeration economies and therefore provides room for these efficiency gains from the allocation side of the tax. This is in a nutshell the mechanism that we have that then allows for this trade-off between the distortive and the income effect of the tax. And then we check whether it could hold in a realistic case with our simulation for the carbon taxing in the European Union. In particular, what we do is that we simulate the evolution of the global economy with our model over the 21st century, all the way up to 2100, in a scenario with and without carbon taxes. And important, without taxes, our model is going to convey outcomes such that they're going to be equivalent to the RCP 8.5 scenario, namely that the economy is going to grow at growth rates and productivity growth rates similar to what's the growth rates of nowadays. In terms of the environmental outcomes, it's going to grow the temperature by about 3.7%, and many of other things that we use to quantify the model. But then in the scenario with taxes, we're going to do the same simulation, but from the year 2021, European Union is going to be taxing carbon. And then we're going to be able to compare the outcomes of the model along several dimensions, both disaggregated all the way up to the grid cell level, aggregated at the country, region, or even global level in terms of sector outputs, so the size of the economy, population, welfare, even the environmental side in terms of emissions, temperature increase, and many other things. That's why it's an integrated assessment model that contains all of these ingredients that can be compared across counterfactors. We show that this effect that I explained take place for this case of the European Union, setting a $40 by tons of carbon tax, which is a realistic tax that it's within the range of taxing carbon taxes in place in the European Union. And to illustrate this channel that I explained, we do that exercise with two rebating schemes. First, one in which the European Union taxes carbon, but at the same time throws the revenue of this tax in a way, and that isolates and shows really clearly the distortive effect of the tax and really the carbon and economic leakage taking place in the result. And then we add what we call local rebating, which is that the taxing is taking place at the grid cell level in all of the grid cells, in all of the locations within the European Union, and we transferred locally at the local population. I'm not going to show all of the results. In the paper, there are several results. I'm going to here select, for the interest of time, those that convey the main message that we want with the paper, which are the following. First, in this graph here, I show the evolution of sectoral outcome in the left, agriculture, and on the right, non-agriculture, over time in the x-axis from 2000 to 2100, on y-axis percentage changes. Compared regional then, for instance, agricultural outputs over time in the scenario with compared to scenario without climate change. And here, for instance, there are several regions that we stress out the results. Like, for instance, the dashed line, which is the European Union, there are no difference all the way up to 2020. And then in the first year already that the carbon tax is set, we see that agricultural output in Europe drops by about 1%. And in the non-agricultural output, it drops by about 4%. The model has dynamics and endogenous growth. So we see that, especially for the agricultural sector, there is some recovery due to this innovation and growth in the model. But the main message here in these results is that we see that the size of European Union here shrinks, but in sectorally wise, shrinks more into the non-agricultural sector, which makes sense because it's the sector that is more energy intense and then more affected by the tax.
Bruno,
Another thing.
can I make a quick comment here?
Sure.
If you look at the data for the US of emissions intensity at the sector level, I haven't looked at the European data. Actually, agriculture is more emission intensive than industry because they use, machines and a lot of fuel. So agriculture, it was
what we use here, Paula, is not that we're not comparing agriculture with industry. What we use is agriculture with the rest of the economy, and then we use the shares of that. That's something perhaps we adjusted compared to the conference in Sardinia, because you raised that point there, and then we checked that carefully precisely to avoid this. So we have there also services that even though, I don't know, we consume a lot of heating and AC, these sort of things, transport and all of that.
But those are non-traded. Don't you care about the ordering within traded sectors? To determine comparative advantage. I guess you care about the ordering within traded.
Well, here it matters more by which industries are going to be more affected by the tax in terms of then tradables, not tradables. I need to think a little bit more that, but we can follow up on that later on if you're fine with that.
Yeah. No, definitely. Yeah, sorry.
No, don't worry. So in a nutshell, that's kind of the main message of these graphs, like European Union shrinking and shrinking more in non-agriculture. And something that this graph also highlights, it's like the leakage effect that we illustrate with the UK, like as a non-European country is not taxing emissions in our simulation. And there we see that it shifts comparative advantage towards non-agriculture. It really reduces outputs in agriculture and shifts towards non-agriculture because its neighboring countries, European Union, are becoming less competitive in that sector. That actually is highlighted by the same results that I showed before, but not on aggregate, disaggregated, that we see each grid cell of our setup, we have red colors with negative changes or blue colors with positive changes. So we see here clearly like the UK shrinking its agricultural output and increasing the non-agricultural output. And we also see some border effects on the neighboring countries of the European Union because of the changing comparative advantage of European in that sector. This is just to illustrate this distortive effect of the tax, not considering the retransferring of the tax revenues. So what happens now if then there is local rebating of those revenues? Two things that are come drastically clear from the equivalent graph. We see, first of all, the European Union reduces much more its sectoral output in agriculture. So before it was about 1%, now it's almost 5%. But perhaps surprisingly, it was at least surprising to us the first time we saw that European Union increases its non-agricultural production. And the reason is that, as I'm going to show next, is that by generating agglomeration in the high productivity, non-agricultural regions of Europe, and especially because the comparative advantages of Europe is much larger in non-agriculture than agriculture, it generates this agglomeration force at Europe's core. That is shown really, really clearly in this equivalent map across locations in Europe. We see that the core of Europe really drops by very much its agricultural output. And overall, we see that in the core of Europe, there is an increase of about 4 to 5% of the non-agricultural production. We see also very clearly the role of geography with this border effect and the role of distance to Europe, and especially in agriculture here from Africa and the eastern side of the borders. And so in a nutshell, what is showing is precisely this: the European is gaining comparative advantage in this non-agriculture, and quantitatively, what happens is that compared to the other scenario in which European Union was worse off in terms of real GDP, population, and other outcomes, we see here that now European Union becomes better off. And these are kind of the two graphs that summarize the results or the main message of the paper. And with that, I will conclude very quickly. We have here in the x-axis the levels of carbon taxes, and 40, it's the result that we are using in all of the results that I shown before. And the y-axis, we have the percentage change in several outcomes. For instance, the change in the aggregate real GDP in the European Union and the aggregate population in the European Union. And we see that for values of carbon tax up to about 50%, the European Union as a whole, because of this reshaping of factors of production within the European Union is better off. And also it receives more population. So it becomes more populated because of this income effect and attractiveness of the European Union. These values are not kind of immense. It's not that the European Union is becoming very rich, but the main message we convey with this is that then comparing this trade-off between the distortive effect and this inefficiency of carbon taxes because of leakage, we show here that at least the European Union is not incurring into a cost. It is able to reduce emissions, it is, but avoiding this leakage or this loss in real income due to the hypothetical leakage because of this agglomeration effect. And I also show that the world becomes better off because of this reallocation. So that is the main message that I hope you got convinced or at least understood clearly what we are conveying with the paper, which is that an unilateral carbon tax in the European Union, where resources are locally retransferred, acts as a place-based policy that favors the high productivity industrial or non-agricultural core of the European Union by attracting people, and also that reallocation makes the global reallocation of factors more efficient, increasing global welfare. And the main message we convey is more general in the sense that by choosing the right tax and rebating scheme, a policymaker can achieve an environmental policy goal by avoiding this leakage effect that traditional in the literature has been documented. And this is what we are not aware of any other evidence or results in the academic literature, and that's what the main message we convey with this paper. I apologize for this extra minute, and thanks very much.
Thanks a lot. So I open the floor now for a discussion, but as moderator, I was told I get the access to the first question. So let me just go back to the issue that we were talking about before. So imagine that there is a single sector, just to simplify, a single sector, and also imagine that there's no migration for a second. And you impose this energy tax. My sense is that in this case, there is no reduction in the supply of the good. Imagine even that there's no energy and you just have a production tax of the one good that you produce, right? The supply curve is perfectly inelastic. There's no reallocation of sales to the domestic market, so you don't export less. Since supply doesn't contract, then the price doesn't increase, so you get no terms of trade gain. So that's like a classic case where nothing's going to happen. All the incidence of the tax is going to fall on wages. The wage is going to fall, then you get the rebate, and people are exactly the same as they were before, right? This would be a tax that has no implications. So I'm kind of starting from there. And then can you walk me through how I go from that kind of neutral result to the one that you have in the paper?
In a nutshell, is the migration side, right? Because you said in this very illustrative example with no migration, but not having a one-to-one mapping between the increase in the, not having any change in real income per capita, as you said on this example, but if that changes is actually considering then the rebating, it happens that the real income per capita increase in that location, then we will have...
What I was saying is with the rebate, income doesn't change.
So maybe let me also...
Oh, hi, Klaus.
Hey everyone. Thank you for all being here. So Andres, your question is one where every location is producing the same good?
No, let's say it's Armington and every location is producing a different good.
Everybody's producing a different good, but then say if so we have a production tax, let's say, right? If the production tax, if nothing else, I mean, the immediate effect is that the marginal cost increases, right? The marginal cost of production increases, right? That pushes up the price, right? Now you say, well, if the price goes up, if there's no, depending on the elasticity, right? Then of course the revenues will drop. If the trade elasticity is low, the revenues will drop a little bit. If the trade elasticity is very high, the revenues will drop much more, right? Because, you know, if I sell my good at a higher price, you know, the effect on the revenues will depend on the trade elasticity, right? Now, once you rebate back the tax revenue, depending on how much that initial drop was, income may actually go up or not go up. So the only case in which income wouldn't go up at all is if you say the initial drop in income is such that the price doesn't change at all. But that would happen if, say, if the trade elasticity is infinite, right? Then it's as if the world price is given to me, right? Which would be the argument, like in a market where everybody's producing the same good, the world price is given to me. So even if I put a price, I have to keep selling at the same original price as before. Then all the incidence is going to fall on the local wages. Then I add back the tax rebate, and nothing has happened. Right, but if the elasticity is not infinite, then the drop in then the price will actually increase somewhat. The price won't stay the same because the price is no longer given by the world market. So the revenues will drop, but if that drop is not that big, then if I add back in the rebate, the relative income in these places may increase.
Okay, my thinking was incidence if the supply curve is perfectly inelastic. So it doesn't depend on the elasticity of the demand curve. It's just, you know, if the supply curve is perfectly inelastic, we know the incidence is all on the supply, and then the wage falls exactly to compensate for the tax, and then the revenues, when they're given back to workers, then the workers are exactly the same as they were before. But I may be missing something, and we can talk after. I don't want to take all the time on that. Paula.
Oh, we can't hear you, Paula.
You're muted, I think.
Yeah, I just actually wanted to come back to this. I think this is really the optimal tariffs argument. You know, there is equivalencies between production taxes and optimal tariffs. The fact that there is this production tax is going to reduce supply, and that, you know, to the extent that whatever the price is not the optimal monopoly price, is going to increase total revenues. So I think that is the argument for the increase in welfare, that this is going to generate the positive terms of trade effect.
No, I mean, export tax and production tax are different, right? The reason why
it's going to, a production tax is also going to reduce supply, and is going to generate a positive terms of trade effect if the elasticity, is smaller than 1. So I think that is what is happening there.
I mean, at a very basic level, what is sorry.
There is a paper by Gino Ganci and Paolo Epifani making this point about, it's a similar point. They say that openness increases the size of government because there is this externality when you tax, that part of the tax burden goes to worsening your, improving your terms of trade, and is paid off by foreigners. So I think that the mechanism here, I think it might be similar to what they have in their paper.
We will check.
Yeah.
We will definitely
check. So maybe just very quickly, the global efficiency gains come only from the fact that the pre-existing spatial equilibrium is not efficient. And what the redistribution of income across space is doing due to this carbon tax is it's bringing us closer to an efficient spatial equilibrium. Because remember, in optimal tariff, it may be good for you, but it's globally not good, right? Because if you have a perfectly competitive economy, then optimal taxes may be unilaterally beneficial, but they will never improve global efficiency. Here global efficiency increases because the pre-existing spatial equilibrium is not efficient. So the parallelism to the optimal tax argument only comes through maybe what Paula was talking about, through that terms of trade effect, through the fact that the local prices are being pushed up because of an increase in the marginal cost due to the carbon tax. And if that doesn't cause a very big drop in local wages, then once you rebate back, it may actually lead to a relative increase in income in places that are more hit by the carbon tax. And that spatial reallocation then causes a migratory response whereby more people are actually moving to high productivity regions, and that is correcting this initially spatially inefficient equilibrium, and that's how we can get welfare gains in the aggregate.
I guess related to this very point, what is it that's causing that initial spatial equilibrium to not be efficient, and sort of how are you estimating the extent to which it's not efficient?
But we actually does not, right? We found that out by comparing, first of all, these two results, like with and without, and then also by playing with parameters that intensify or reduces the intensity of that effect, we get results that are qualitatively go in the direction that we expect. But we not really quantify how inefficient is the pre-existing spatial distribution of economic activity and to the extent that then how much the carbon tax corrects that. But perhaps this is something worth thinking about.
I mean, if we were to switch off if we were to set the parameters, say, of the agglomeration economies, and if we were to set these externalities to zero, then obviously we would be getting a negative effect globally, simply because there is obviously some distortionary effect of this tax, at least on impact. In the long run, it's different because we're obviously still correcting the carbon externality, and we're affecting temperature in the long run, etc. But on impact, welfare would go down if we set the externalities, the spatial externalities, the agglomeration externalities, and the congestion costs externalities, if we were to set those to zero.
And the key part of the story would also happen if, forget about carbon emissions, just Europe imposes an optimal tariff. Its income goes up, and then people move to Europe, and because of agglomeration externalities, the world economy gets better off, more efficient.
I mean, you could say, why are you doing this thing and you're sort of correcting a spatial inefficiency? Why aren't you guys thinking about what are optimal place-based taxes that would take care of this issue. The reason why we're coming at it from this angle is because these optimal place-based taxes are not part of a policy discussion, whereas obviously unilateral carbon taxes are, and somehow the message is, the positive message is that these unilateral carbon taxes are less costly than they appear, right? And so if you think about political resistance, especially in the short run, because we're getting these welfare effects on impact, right? People sometimes say, oh, carbon tax is like an intergenerational transfer, right? Today we pay the price to make the next generations better off. Here we're giving an example where, you know, actually even on impact, there are global welfare gains from this tax. And so it's somehow saying, you know, what seems politically difficult to achieve may actually be politically easier to achieve than we think. I think that's kind of the message.
Yeah. Very good. Thanks a lot, Bruno and Klaus.
Thanks to you and for all of the comments.
And for all the questions. Yes. All right. Very good. So now we move to the last presentation by Farid, Farrokhi, talking about can trade policy mitigate climate change? Farid.
Thank you very much. Let me share my screen. Can you see my slides well?
Yes.
Okay, great. Let me just try to all right, great. Thank you very much for including this paper in the program. It's great to be here. This is joint with Ahmad, Lashkaripour. And our starting point in this paper is this growing concern among experts, both in academia, also among policymakers, that recent and existing climate agreements, such as Kyoto Protocol or Paris Agreement, they have failed to deliver a meaningful reduction in greenhouse gas emissions. And the reason seems to be the incentive structure upon which these agreements are built. Here is a quote from Nordhaus's AR 2015 paper, where he says that the fundamental reason is the strong incentives for free riding in current international agreements, as many countries have an incentive to rely on the emission reduction of others without taking proportionate domestic abatement. I forgot to mention that my co-author Ahmad, I think, is with us, and if you have questions during the talk in the chat room, he can keep the chat room alive. Anyhow, there's this free riding issue that makes these agreements on global agreements on climate not to deliver a meaningful reduction in CO2 emissions, and several policy proposals have emerged to address the free riding issue. And typically they try to combine carbon pricing with trade policy. And among those, two of which have gained particular traction. And so let me pause here and explain these two policy proposals and put them in some proper context, the way that we want to understand them and study them in this paper. So in proposal one, climate conscious governments can incorporate carbon border taxes, sometimes they are called carbon border adjustments, in their package of trade policy to influence CO2 emissions outside of their boundaries. And this is not just a theoretical possibility, this is now a key part of the EU Green Deal. But there's also another, you can take another perspective in order to how to combine trade policy and climate policy, and that's proposal 2, in which climate conscious governments can form what we may call as a climate club and use their collective trade penalties to incentivize otherwise reluctant governments to join the club. Now, there's a similarity between these two proposals in the sense that they both bring trade policy to help the issue of agreements on climate issues. But there's also a stark difference between the two, because in proposal 1, it's as if you say that global agreement is not feasible. So the best I could do, in fact, is the second best by unilateral action. But in proposal 2, you're saying that while climate is a global good or CO2 emissions are global bad, so unilateral action cannot be effective. This is sort of the presumption here. So, and what is the issue here is the architecture in these global agreements, so that let's just come up with a better one. And in the literature, there are a number of studies that examine different versions of these policy proposals. On the theory side, typically, they are not designed to bring to multi-country settings. And on the quantitative side, they lack a notion of optimality. So typically, they cannot quantify or evaluate the full potential of these policy proposals. And sort of what we want to bring both the theory and some notion of optimality of policy regarding these two proposals, and we want to bring that to data for quantitative analysis. In 3 steps in particular, first, want to develop a multi-industry, multi-country general equilibrium model of trade augmented to accommodate CO2 externalities. Then we produce an envelope theorem or envelope result that helps us characterize analytical formulas for these optimal taxes, so that we can characterize them under G feedbacks. Then we map the model together with optimal tax formulas to data on many countries and industries to evaluate the effectiveness of carbon border taxes and the climate club proposal. So let me start with the theory, and for the sake of time, I'm going to keep it like with less equations at some high level. I'm happy to go over more details during or after the talk. So this is a multi-sector Krugman extended to have carbon input use, or like you could write it down also as an extension of classic work of Copeland and Taylor, abatement specification, and the market structure is monopolistic. Competition. There are multiple countries, typically my notation, I or J, and each endowed by a given endowment of labor, L bar I. There are multiple industries, typically indexed by K, and each served by a mass of symmetric firms. And there is free entry, like the Krugman model. And on the demand side, we have 3 tiers of preferences. On the very upper tier, there are Douglas demand across industry level composite goods, between composite of agriculture, composite of chemicals, etc. Then within industries, like within chemicals, there are varieties coming from different countries, like Chinese varieties, US varieties, etc. And here we have the Armington assumption, and elasticity of substitution is sigma for industry K sigma K, and sigma K minus 1, so is the trade elasticity. And within each industry origin, like chemicals from China, there are products from different firms with the elasticity of substitution gamma K that governs the markup. And then on the supply side, we have costly entry by potential entrants in each country industry. Upon entry, a firm's production takes a form of a CES aggregator between labor and carbon input. And the elasticity of substitution between these two is this var sigma parameter, which I've highlighted with red color, which governs sort of the relative demand for carbon. And here firms face a trade-off between marginal cost and measures of carbon intensity, in particular CO2 emission per unit of output. So faced by a higher carbon tax, that means that they are going to choose less carbon input, so marginal cost goes up, but CO2 emission per unit of output goes down. And if you are familiar with the classic work of Copeland and Taylor, we could equivalently specify this trade-off in terms of firm level abatement. In any way, it's just we have these firm level behavior. We could just aggregate them to the industry level variables in each country industry, where scale economies also show up, driven by firm entry, like the Krugman model, and the model collapses to constant returns to scale in a limiting case where this gamma, the elasticity of substitution between products within industries, goes to infinity, so there are no markups. Now, let me just walk you through sources of inefficiencies and the way we are going to think about instruments of policy and objective functions in this framework. And for that, it matters whether we are thinking about the market outcome from unilaterally from one country's perspective or from the global perspective, which was also some important theme in the previous paper. Here, from country I's perspective, let me just call it like home country. Firms in every location, in home or abroad, they do not internalize their CO2 externality on residents of the home country. And the government of the home country just is caring about residents of the home country. In addition, export and import market power remains unexploited with respect to the rest of the world, which provides some rationale for terms of trade manipulation. Now, from the global perspective, firms in every location now do not internalize their CO2 externalities on residents all over, in all countries. And so there is this difference between like unilateral perspective and global perspective about CO2 externality for whom. In the unilateral perspective for residents of my own country, in the global perspective, residents of the earth. And from the global point of view, free trade is efficient. And in both cases, whether unilateral or global, the different degrees of scale economies across industries can create misallocation, which provides some rationale for industrial policy, in fact. And so what are the instruments that can, with which a government can achieve the first best, unilaterally, I should say, because there are more taxes should be available in that case. There are domestic carbon taxes, I'm calling them TAO, and they're in each country I paired with industry K. Production subsidies in each country, industry IK. There are import tariffs and export subsidies. And what they do is that domestic carbon taxes, TAO IK, induces firm level reduction in the use of carbon input. And there are other taxes, production subsidies, import tariffs, and export subsidies. And what they do, basically, they create a wedge between producer and consumer prices, either for domestic transactions or for international transactions. From here, we can define objective functions. I'm calling them welfare of countries. And the way we do that is just probably the simplest way we could integrate sort of like this utility from climate damage and indirect utility from consumption. Here, WI is country I's welfare, and it has two components. The first one is the indirect utility from consumption, and this is income of country I by I, and this P tilde I is the vector of consumer prices in country I, including what you import. And this delta I is that this utility from a unit of CO2 emission. And what matters here is that CO2 externality is a global externality, and Z here is CO2 emission from country N, industry K, but the externality should take into account that this is the sum of CO2 emissions from all countries and all industries. So this is country I's welfare. And if you sum over all those WIs, we get W for the entire world, and that's global welfare. Now I'll show you in a second, like the full formulation of, or the full results for the optimal taxes. But just let me here pause and highlight the difference between optimal carbon tax in the case of unilateral versus global. If it is a unilaterally optimal carbon tax, then the carbon tax should take into account that this utility of CO2 externalities to the residents of country I, so it's just this delta I or delta tilde I, versus what is globally optimal for carbon tax, which is the sum of those. And so the first one is smaller than the second. And for some countries, there are many reasons for the difference to be really large. And so what this means is that it creates incentives for governments to lower carbon taxes from the globally optimal tau star without I, sorry, this is without I, to unilaterally optimal tau star with I. And this is sort of a race to the bottom, or why there are free riding incentives. And so And so the two policy proposals I was mentioning in the beginning, in the case of carbon border taxes and climate club, they are meant to nullify these free riding incentives. In the first case, in the case of carbon border taxes, we want to target untaxed transboundary CO2 emissions. And in the case of climate club, we want to use collective trade penalties to deter free riding in order to achieve an agreement on climate internationally. But let me just also show you these are like for domestic carbon taxes, but how about like other tax instruments? What is unilaterally optimal for import taxes or tariffs takes this form. And I want to highlight that it has two components. The first one, which is this gray, shaded gray omega, it's a function of inverse export supply elasticity. And if we didn't have like any care for climate, then the only thing that we would have is just this term that has been also studied elsewhere. And what it does is that it is for manipulation of terms of trade to the benefit of the home country. But there's also this other term, which is what we may call as carbon border tax. And what it does is, to the extent that a government can, it taxes untaxed emissions or production outside of its boundaries. So it has three components. The first one is CPI adjusted its utility for country I per unit of CO2. Then there are CO2 emissions per dollar of output in the country from which we are importing. So the more carbon intensive our import is, the higher this carbon border tax would be. And then there's also lastly a correction for scale effects that you want to take into account, not to mess with scale economies. And so just for the sake of time, let me mention that we should also have optimal export subsidies, and by Lerner symmetry, it is understood that it's combined effect of import tax and export subsidy. That matters. However, similar to optimal tariffs, optimal export subsidy consists of two components. One is terms of trade driven. The other promotes exports that can compete with carbon intensive foreign varieties to any destination, and we may call it carbon border subsidies. I'm happy to show you the exact formula, but just for the sake of time, I found it better to just deliver the intuition in terms of the two components that it has. And also for production subsidies, whether it is unilaterally or globally, package of policy, they are carbon blind, as we have addressed other externalities by their own instruments of policy. So it is carbon blind, and it just restores marginal cost pricing. So what we want to do with these taxes for evaluating the effectiveness of carbon border taxes or the climate club is we want to put them to work in the following way. First, by adopting optimal carbon border taxes and subsidies, governments can achieve a second best using these border measures. And so we could use those unilaterally optimal policy formulas. Second, in the case of climate club, which is an alternative view to the problem, optimal trade penalties, importantly including the terms of trade component, can be used to enforce reluctant governments to join the club and to achieve international cooperation on climate. Now, with these, want to bring the model to policy analysis in a quantitative way. Let me just highlight one feature of this model, and we share this feature with other quantitative trade models with optimal policy formulas in general equilibrium, that equilibrium prices and quantities, they depend on optimal policies or optimal taxes on the one hand. On the other hand, optimal taxes, as you might have already noticed, they depend on equilibrium prices and quantities. So in order to solve the model, we should solve both of these together jointly. And the way we do that, we use hat algebra, which sidestep the need to recover productivity and trade costs. But we would need a set of sufficient statistics, and they are trade shares and currently applied border taxes, as well as shares for expenditure, revenues, employment, intensity of carbon use across industries, and cost shares of them, as well as this utility of carbon in each country. And also we take the value of social costs of carbon at 31 from the US Interagency Working Group. And then there are three structural elasticities in the model: trade elasticity sigma and markups, both of which are industry specific, and carbon demand elasticity, with which we estimate them using standard techniques in the literature. I'm happy to talk more about the mapping of the model to data, but let me go over how we put them into work for evaluation of these two policy proposals. In proposal one, as I already mentioned, governments want to incorporate carbon border taxes in their package of trade policy to reduce carbon emissions outside of their boundaries. So the way we think about it here, the way we implement it, is that we simulate a non-cooperative game, so it's a Nash game, where all countries simultaneously adopt their unilaterally optimal carbon and border taxes. And so from the baseline, we go to this counterfactual and want to understand like how much emission reductions, carbon emission reductions would happen. So this is a summary of our results for this proposal one. And here in panel A, I'm showing the results for this non-cooperative game. And I'm benchmarking that to the case of global cooperation so that we have a sense of comparison. And I'm also reporting for select set of countries, the reduction or the change in CO2 emission, in the change to real consumption component of welfare, and in total welfare, which also includes this utility from carbon. And so let me just highlight the impact on global CO2 emissions in the case of non-cooperative versus the case of global cooperation. In the case of non-cooperative outcome, global CO2 emissions reduced by only 0.6%. In the case of global cooperation, that is 61% reduction. So we can say that non-cooperative taxes, and by that we mean carbon border taxes, can replicate only 1% of the globally first best CO2 reduction. We've done a number of different robustness checks to this exercise. And across all of them, like, for example, what if we have constant returns to scale technologies? What if we have different parameterizations of the model? And we consistently find that this number in the case of non-cooperative is very small compared to global cooperation. Here it's just 1%. It could be 2%, 3%, or less than 1%, depending on the exact specification. But the question remains to be why the effect is so limited? And we think that two reasons are responsible. The first one is that, and we could know this also just by looking at the data, that a large share of CO2 emissions are generated in industries that aren't that tradable after all. So for example, 2/3 of CO2 emissions in the world are generated by industries with a trade to GDP ratio that is quite modest, like 10%. And then also the other impact is that carbon border tax targets origin industry pairs, not firms. So it is not granular enough. This is an important point, but let me, for the sake of time, go to proposal 2, where climate conscious governments can form a climate club and use their collective trade penalties to enforce cooperation. And this is very much inspired by Nordhaus ideas. So here's the structure of the game that we are envisioning, that there should be core members that commit to the rules of membership, and only other countries are going to play strategically. So if you are a member country, then you are going to impose 0 taxes against other member countries, but you're going to impose unilaterally optimal trade taxes against non-members. So this is sort of the trade penalty that you impose against them to incentivize them to join. And if you are a non-member, also you can retaliate against members. And in terms of trade taxes with respect to other non-members, you do nothing, you stay at status quo. In terms of carbon taxes, if you are a member, you reduce your unilaterally low value of tax to globally optimal, which is higher. And if you're a non-member, you stay at a status quo. Here, by joining the club, a country faces the following trade-off: that it incurs a production loss by adopting a higher carbon tax, but it can escape from members' trade penalty. So what we find is that the Club of All Nations is a Nash equilibrium, no matter who core members are. And this graph is showing that result, that once the global optimal policy is achieved, then no country has an incentive to deviate. And the graph is showing for each country welfare gains of staying in the club versus unilaterally withdrawing. However, the challenge and the difficulty is that the Club of All Nations does not have to be the unique Nash equilibrium. There could be also other Nash equilibrium and and those in fact depend on who core members are. And this is not an easy problem because you face the curse of dimensionality. There could be all sorts of different configurations that can possibly form a club. And so we have developed some techniques to make progress over that. And what we find is that because EU is the most climate conscious government in our sample, and I think that's sort of the very relevant assumption, is that we first suppose that the EU is the only core member. And we find that with that, in addition to Club of All Nations, the Club of Only EU is also a Nash equilibrium. And so we cannot rule out the non-cooperative. This is going back to non-cooperative, in fact. But if US also joins EU and becomes a core member, now the collective trade penalties from these two countries are going to be greater. And one of to see whether it is sufficiently great so that we can achieve the globally first best. And we find that, yes, the Club of All Nations becomes the unique Nash equilibrium. And the way we solve this is that, like by iterations, we start with core members, then we see that regardless of what others are doing, who is going to join. And we see that in second round, Canada and rest of the world will join. Given that these two countries joined, in the third round, a number of other countries join. And in the last rounds, also China, Brazil, and Indonesia will join. And we can find that CO2 emission reduction at the level of globe achieves the globally first best. And 8% of this 60% is accounted by EU and US, who are core members and do not play strategically, but the rest, which is sort of the lion's share of it, is just by other members. So I know that I hope that I didn't pass my time, but it's just like carbon border taxes can reduce CO2 emissions only to a limited degree, but Climate Club can be very effective, but its success depends on the makeup of its core members. Thank you very much, and I'm happy to have discussions.
Thanks so much, Farid. Super interesting. Let me just start with one question and then take other questions from others. So the key result is fascinating, right? That the Climate Club seems to be so much more effective. I just wonder to what extent you're giving a fair opportunity for carbon border taxes to play their role. In particular, as you were saying, firms have no incentives here to lower their emissions because the carbon border taxes are going to be based on the industry level emissions. And then you would say, okay, then the government of exporters, say to Europe, that has a carbon border tax, would have the incentive to tax carbon emissions in that industry or in that country as a whole. But if I understand correctly, the Nash equilibrium concept that you are looking at in the carbon border tax case is not going to give, you're not kind of giving, you're not giving, the game is not sufficiently complex, or the equilibrium concept, to allow a country to say, I'm going to impose a carbon tax so that then the tax I have to pay in Europe is going to be lower. So maybe you can say a little bit about that, and then I'll take more questions.
Sure. No, this is a great point, and I just want to highlight that we understand that there can be sort of a spectrum of policy proposals between my proposal 1 and 2, and maybe you were also heading there. And maybe one in between case is to think about these carbon border taxes not to be defined at the level of industries or goods, but at the level of firms. And I think one proposal that I know a little bit of is that the default for any firm is that you should pay the tax unless you prove that you have taken the required abatement. And so it might be, and so I understand that I'm maybe walking beyond the scope of the paper now, but it looks like that like a Melitz type setup can help us get there. Like that there are additional export costs to penetrate a market, and that additional cost is exactly this firm level carbon border adjustment, and the magnitude of that could be the difference between my country's domestic carbon tax and if it is going to export it to EU, their domestic carbon tax. But we should one thing that I want to have like good data on is like what are sort of the costs that what is this cost exactly? Maybe if there is some implementation of the policy, we could use it to recover these costs associated with it.
Thanks, Farid. Allan?
Thanks, Farid, for the presentation. I was interested in, so I think you're thinking about CO2 emissions as kind of a global pollutant and having impacts sort of everywhere, and maybe that's not internalized. And I was wondering for your kind of climate club results, suppose you had local negative impacts as well. Would that kind of, for example, particulate matter, or in Indonesia, you mentioned right now only joins in the 5th round, but they have forest fires all the time. Some of that gets blown over to Singapore, but then Singapore regionally exerts pressure on Indonesia. Where you think in the EU, for example, locally the EU will be better off, but then there are political benefits maybe to kind of acting on climate. So if to the extent that you have those local benefits of acting come in, does that kind of strengthen, I guess, your climate club result even more? Where those lead actors currently would actually come in earlier?
Yeah, that's a great point. I should hear more from you on that. Particularly, I know you've done great work on the case of Indonesia. But were you alluding to sort of political institutions that make some of these countries more willing to join?
Yeah, it can be political institutions if you're talking about Europe, for example. But I guess in this particular example, since you have Europe as a core member, what's kind of holding it back is the countries that come in later. And so that's why I looked at Indonesia, because currently you have Indonesia coming in at the very end. But then to the extent that Indonesia doesn't want forest fires and doesn't want kind of palm oil instability or all of this stuff, if you add that in on top of, you know, CO2 is a global emitter, they don't care that much about that, but maybe they care about particulate matter.
So I think
if you
it's
add
just
that in, maybe
within,
they'll come in earlier.
no, maybe it's just within the scope of the paper. It's a richer way of calibrating these utility parameters.
Yeah, or even for Indonesia, how much more, like what is the range of benefits that they would need to come in the 2nd round instead of the 5th round? It's, you know, an extra $10 per ton of carbon. And then you can say something like, well, look, particulate matter has big damages. Maybe that's the source of this $10 that we would need in order for those actors that currently come in later to come in earlier.
Sure. Just I wanted just to highlight that these rounds are just steps to solve the climate club proposal, but the model is not dynamic.
I see. I see.
Farid, can I go back to the previous point?
Sure.
So let's say that so the what you were describing about giving incentives to firms sounds super interesting, and doing it with the Melis model in the way you were describing sounds very promising. But let's put that aside, and let's say that it's all at the industry level, and so it's then the country that has to just set the policy. And so if the government, so your equilibrium concept for carbon border taxes doesn't give an incentive to I'm asking, I guess, the exporting country to increase the carbon tax, knowing that would lower the tax that they would have to pay as they export to Europe or any other country that has carbon border taxes, or does it?
So I think it does not do that directly, maybe through general equilibrium effects that is happening, because it's a simultaneous one-shot game. But I think if we put it in a sequential game, depending on how we do it, we may open some room for that.
And so right now, can you just explain so it's simultaneous move, and so each government is setting the carbon tax, deciding whether to have a border adjustment tariff, or they all do that? Can you just go through that?
Right. Everybody is maximizing unilaterally its welfare function in a one-shot simultaneous Nash game. And so what you described earlier, I don't think it's happening here directly. But if it was like a sequential game, like maybe it's Stackelberg, so EU was playing first, and then in playing first, EU would internalize that its policy would have implications for others, because EU has placed first and they do not re-update what they do. They commit to that. And then the follower guy, knowing that EU has sort of committed to that, will know exactly what you said, that if I increase my carbon border tax or domestic carbon tax, then the difference between my domestic and EU's domestic would be different. And so our firms are going to end up paying, facing less barriers to trade for this. But I think for that, we need this Stackelberg or sequential game. Okay. And I think that could be somewhere in between of the climate club and sort of what we said as proposal one, because there's this notion of committing to a policy by the first mover.
So can I also add one thing, Andres, to this? I think that's exactly right. But also, I think in addition to what Farid said, when we are solving for the optimal policy, what the assumption is that we're solving for the optimal policy given applied taxes in the rest of the world. So the optimal policy problem does not internalize that applied taxes in the rest of the world are a function of my policy choice. So given applied taxes, which include carbon, border, and domestic taxes in the rest of the world, we solve for the optimal policy of a country. So I think what you're thinking is potentially saying that my optimal policy also internalizes, which will be relevant in a sequential game, that if I set a higher carbon tax, I'm going to pay a lower import tax, which the optimal policy does not internalize that.
Great, thanks. Doug?
So I had a question which was really about clubs, and this seems like an interesting case where normally I think, I don't belong to any, but normally I think you have to pay to join a club. This seems like an interesting case where you could imagine the club wanting to compensate certain countries for joining and becoming members because it changes it changes the Nash outcome. So I was wondering, in a sense, whether the negotiation space, which is already complicated here, is one that isn't even more complicated, that you could think about the US and EU deciding, or just the EU by itself, deciding to make a side payment to some other country or set of countries to join the club to change their benefit calculation. And that seems like a space that would be, you'd think about strategically whom to invite, and out of the potential additional benefits that the EU receives from expanding the size of the club, you can imagine quite a complicated game taking shape. Anyway, that was my question. If there's not time for this, Andres, I'm happy just to take that offline.
Maybe Farid can just say something in 20 seconds and then we wrap it up.
Sure. Just in theory, in principle, you're absolutely right, because once we solve for the global optima, it is understood like the second welfare theorem, it should come with transfers so that everybody has like a Pareto move. And so we could find those sort of the bound on those transfers that everybody is getting better off and put it in this structure. What is a bit hard for me right now to think about is like how we can put that into this proposal so that still the proposal is free riding immune. And I'm happy to continue the discussion offline.
All right. Very good. I think this has been a great session. Thanks for the presenters and the